Hello and welcome back to the Game Dev Show. I'm here with Yori, Jason, and Andrew to talk about game development, Unity stuff, some shader stuff it sounded like, and all kinds of other interesting things. If you have questions or comments, just drop them in the chat. Everybody will be watching. And before we get started, I got to make two really quick announcements. One, I'm going to be semi-AFK for the first part of this stream. I've got a little baby that needs some food, and she'll scream at you guys if I try to feed her in front of you. And number two, the Game Dev Guild Mixer is coming up in about 3 hours. So everybody who's registered for the conference, make sure that you check for the link. There's a link down below for the Mixer, and there's also a link in email. But if you registered afterwards, just make sure that you go to the link down below and join us at noon. It should be a lot of fun. There's going to be a lot of people there and just a lot of interesting discussions. Also, for the first, I think it's like 5 people, there's a quick discount code, Fast Pro, for $50 off the Game Dev Guild conference. It's only good through the end of this show, and there's only a couple of them. So if you wanted to join, now's a chance to get a quick last-second discount before we go live with the event. And the full event starts Tuesday. The Mixer is today. Should be a lot of fun. Lots of interesting stuff and a ridiculous amount of assets in the bundle now that we're giving away as well. So thanks everybody for joining us. Thanks for coming out here. If you have questions, anything, drop them in chat. I'm sure we'll be answering them. And thanks guys for being here. Anybody want to say hello or
Hi.
Got anything?
Hello.
Howdy.
Oh, look at that. 3 hellos. All right.
That's what you asked for.
That's perfect. All right. By the way, are you guys coming to the Mixer?
I'd like to if I can.
Perfect. Yeah, I'm gonna make sure that you're on there. If you're not already in there, you should definitely be.
I don't think I've set myself up yet.
Yeah, I need to set it up. I'm going to try to see if it works on mobile. I'll be driving to a tabletop meetup an hour away, so we'll try
awesome.
mobile.
That sounds fun too, though. Yeah. Well, hopefully you're able to get in there and join us and have some fun with that. I think that people will really enjoy that and probably want to hop in there and start asking you random questions. So it should be fun. Cool. Well, with that said, I'm gonna disappear for a minute, go feed a baby, and leave it to you guys to kick off the discussion.
Sure. We can actually already start because there's apparently already questions in the chat. Yeah. Raku asks, if I want to go for PC game development, which one should I choose, Unity or Unreal? Any of you want to take that?
They both make games, so I say go for it, whichever one you prefer.
That's an interesting take, though I think it's a bit more nuanced because some of these engines have better capacities to work for certain types of games than others. For example, Unreal is actually pretty lacking in the 2D department, while in Unity you have the fully featured URP 2D release that has quite a lot of tools to make your life easier right now. But if you're using 3D, Unreal has all the latest crazy technology about Lumen, which lets you mess with lights way easier, and Nanite, which lets you not care about the quality of your assets, downgrading the performance of the game too much. There is a cost there, it's just not that big. So I would say the question kind of depends on what kind of game you're trying to make. So do look up the feature sets that you need. In general, Unity would be easier for a beginner. That's my own take right now. Jason, do you have any take there?
I'm going to give the same take I always give to the very similar kinds of questions that fall into this category, which basically boil down to that's not a... There's not enough information in that question. And what I mean by that is if you turned to me and said, I need to cook some food, what should I cook? It's like, I don't know. Are you cooking a Christmas dinner? Are you cooking are you making a sandwich for yourself? I don't really know. The truth is, my general advice is the same for all of this stuff. You don't start out with your first meal by doing a wedding party, right? You don't start out with your first anything by going to a high-end extreme. And people look at Unreal and go, it's very shiny. It's like, yeah, it is very shiny because it's got a lot of powerful tools that you need to learn how to use correctly that you won't know how to use correctly. So I usually don't recommend starting there. 2, if you're going to try to make money, Probably one of the easiest things to do to get your game out there is portability on different platforms. And to date, Unity is still the best for multi-platform support out of the box, the least amount of effort on your part. So if it is your first game, start with something simple like Game Maker, learn the mechanics. If it's something more complicated than that, start with Unity, do something where you have a bit of experience with the programming and you can put things together. If you want to go high fidelity because you've got more experience, move into Unreal. And this will be the same for every one of these questions. Pick the right tools for the job you have and then aim for the simplest version of it and use those tools. I don't think it's that unique or interesting a question. I think realistically, everybody, it's the same, right? No matter if you said you wanted to start woodworking tomorrow, I would probably say something similar. Find a book that says beginner on it and start there, right? Like it doesn't matter what engine you pick. It's a kind of it doesn't like it doesn't matter. It's which tool. It's like when people buy like a really fancy guitar to learn to play guitar. It's like, well, you can learn on anything. You don't need to buy the most expensive thing to learn. You can learn and then pick the one that matches what you end up with later. So just pick an engine and play with it. I usually recommend Unity simply because if there's one factor above all else that I think is most important, is how easy will it be to learn. And in order of resources that are out there, I think there's the maximum amount of resources for Unity in terms of like just people who will give you guides and video courses and tutorials and whatever. There's a lot for Game Maker and a lot of other tools like that too. There's a lot less for Unreal because it's in turn mostly in-house. Now that's growing. There's a lot more of a community building now. But if you're stuck and you want to find someone who's hit the same problem you have, your higher chance to find some help is with Unity. So unless it's your unless you're already moving into choosing different games for different platforms and you're making a decision, if it's your first game, which is probably why you're asking that question, because people who've made a few games don't tend to ask that question, then start with Unity is my usual suggestion. Unless the code scares you because you've never done coding, then go to Game Maker, something like that.
Fair. There were quite a few questions throughout the answer, which was perfectly made, by the way. So there is one that is probably a good follow-up to go through from Jibus. Unreal shouldn't be used as a starting program because it's too hard to learn. Or isn't it harder to learn both Unity and then also eventually Unreal? So this is a bit of a nuanced topic, but they both use the same concepts. It's just that Unity's editor comes less loaded with features for you in advance. Therefore, it's a cleaner playing ground for trying to figure out what you actually try to do and what you actually need to do to get that. For example, when you're starting a game in Unity, a project in Unity, there's literally nothing except the most basic tools to get a scene running. Whatever you put in there is the only code that's going to run in there. And when you're making a project with Unreal, it's a bit different. Usually you have a game mode that you have to set. There is some basic stuff that is always going to spawn depending on that game mode. There are also some extra features that are going to be set up for you, like post-processing, which you may not need or don't intend to have. All of these things happen for you without your awareness as a beginning developer. And so in the past, there was this quite common discussion about how Unreal looks way better than Unity. Well, it's because Unreal started with post-processing set up to like a nice preset, and Unity did not. Right now, Unity already has like kind of a solution for that. If you're starting recent projects in URP and HDRP, they'll actually start you off with an empty scene, but with a post-processing volume. And that's really easy to find because Unity's editor is kind of way more minimalistic, and you can straight up see you have a post-processing volume in the scene as soon as you open the first screen. In Unreal, it's not the same because the starting scene already comes like a bit more loaded with stuff in it. And you have to scroll down a bit more to see all these features. Basically, Unity is a better ground to learn the basics with, but it uses the same concepts as Unreal in regards to making quote-unquote components and then putting them on the actors that you have and seeing how they play out.
I mean, again, I know I keep harping on the same thing because there's a lot of fundamentals here that trickle across to everything. If someone says to you, I want to start learning how to draw anime characters, or I want to start learning how to draw real-life shapes or landscapes or whatever, at the end of the day, you have to learn your geometry and your perspective. Doesn't matter about everything else. That all comes downstream from learning the fundamentals of how you draw shapes with the correct perspective, and so on. Similarly with programming. If you learn your first programming language, doesn't matter which one you pick, the first one's going to take you a while, the second one will take you probably half that, and so on, because the amount of fundamentals is there's quite a lot to learn. And with game development, I really can't stress this enough. People think about game development as learning, oh, well, I have to learn how to program. Sure, that's one part of it. Then you have to learn how to compose a scene. That's a whole other part. Then you have to learn the color, the art, the audio, the level design, the puzzle design, the UI and UX stuff, the saving systems. If you don't understand how persistence works, you have to learn multi-platform support, you have to learn source control. The amount of things you have to learn is huge. And so the idea of saying, oh yeah, but you have to learn it again in Unreal. No, the bits you'd have to learn in Unreal are the Unreal Engine specifics. So if you learn control flow, which is basically the idea of if this, do this, then this, whatever, it doesn't matter if it's a node-based tool or if it's like Blueprints or Kismet before that, or if it's in code. Once you understand control flow, you can do it in one way or another. There are pros and cons to one side or the other, but fundamentally, learning it is going to be the same either way. The question is, do you want to learn it with a lack of resources, or do you want to learn it in maximum resources, and then once you understand it on a deeper level, translate your knowledge to the place with less resources? And so, same thing. If you want to learn to write fantastic prose and poems, you have to first learn the alphabet. So start simple, learn the basics. You don't have to learn it you don't have to start learning the alphabet while you're learning calligraphy. You'll give yourself a headache trying to combine multiple complex things at once. But if you're trying to learn the basics, you'll do better. In fact, if you want to go all the way back, my biggest recommendation for most people, if you've never made anything game-related before, is pick a level creator. Portal 2 has a really good level creator. So does the Tony Hawk's games have great level creators. Pick a game that you like and just play around with a level creator and try to understand at a very core level what makes a puzzle, what makes it fun, why do I like these shapes, how do I block sightlines. There's enough to learn at each incremental step that the idea of jumping into the prettiest engine you can find and try to match a AAA studio is comical. Like, don't do that to yourself. You'll hate the result, right? Start simple, and it doesn't matter what we're talking about. It's going to be the same answer across the board.
So there were quite a few comments about the entire discussion. There is some consensus about 2D being better with Unity, but everything else to go with Unreal. This is something that I kind of concur on myself recently because of the divide that Unity has with 3D projects. Just wanted to comment that it's there. I feel like Unreal is better suited to a team, where Unity works great for an individual developer. It's C# versus ++ on the code side.
Again, that's like low down level. Like, there's so many concerns. For example, if someone says, oh, well, let's just take it for granted that Unity's better for 2D and Unreal's better than 3D. Right. But what about this? Are you an artist? Is it easier for you to put some cubes in a scene, or is it easier for you to draw art? So, like, the question of this engine is better at this thing is irrelevant in the face of, can you draw lots of art, or is it easier for you to learn the code and then put in cubes and make a game that works? It's such a non-starter of a question. It's so pointless to structure, this is better because other teams of this size using this programming language. We're way away from there. Start here and go, what can I do? What do I want to achieve? And then pick the tool that does the thing you want to achieve. Like, start slow. And in 99% of cases, if you're learning, learn with Unity. And if you find Unity is so easy that you want to move up into the world, into Unreal, feel free to do it. But if you're finding on Unity a struggle with the massive amounts of resources, then starting with Unreal is going to harm you in the long run. Like, I can't see a path where it makes sense to throw yourself in the deep end. And then the other thing too, to be completely honest, C# as a language will work in other engines and things. There's things you can do that's easier to play with. But if you start with Unreal and you move directly into their implementation of a node system and C++, you'll have a harder time transferring that unless you're moving into another engine that's entirely C++. There's more stuff for you to play with that's easier to find resources on. Like, if you can find Java resources, they'll look a lot like C# resources. There's a lot of stuff that you can transfer from a knowledge-based perspective. So again, just start easier. I don't know why that's a contentious point.
Yeah, fair, entirely fair.
Makes sense.
Yeah. So there was another question from Saduno Zer about URP or HDRP for a low poly PC focused game. Can HDRP give us the extra oomph we need? So Jason, do you want to take that, or?
I'm just going to say URP is like 99% of projects will be fine with URP. Like, there's very little reason for you to go HRP unless you're actually going to use the features it has, which you probably won't be.
That's what I was going to say is, what features of HDRP would you be looking for?
Yeah, specifically when you're doing a low poly PC game, it's like you're already saying, I'm not prepared to spend the performance cost on better models, better textures, etc. So you do gain free space to do whatever you want with that PC game. HDRP will give you better post processing, but it's also going to tank your performance because all of that extra effect that HDRP gives you takes steps to process. So it's depending on what you want to do with that PC focused game. If you want to eventually port it to mobile, maybe don't go for HDRP yet, because you're going to have problems trying to make HDRP work for mobile cleanly. If you want to go on a low-end platform like the Switch, then again, HDRP is going to tank your performance. URP is basically a minimalist engine so that you can get it to a bigger set of platforms. It's the universal version of the engine, essentially.
Also, like it's not pretty, right? That's one of those things.
Yeah.
It's a massive kind of misconception. Is because there's high definition, people go, oh well, then the opposite of high definition is low def. No, it's not. It's the difference between turning all the dials up to 11 versus having them around 9, and it's fine. The biggest example to me, I think this is a night and day difference. If you use URP, you get realistic light, like a light in the world that bounces around realistically in realistic ways. If you use HDRP, you use a celestial body where you literally place a sun in the sky at a certain distance from the planet and manage the way the light reflects in that way. Do you need that? Like that's one of those things where, like, of course that's an extra level higher, but like the difference between that and using it, if you want a realistic night and day cycle and stuff, sure. But in a small case, and again, you can transfer. Now, I'm not saying it's easy. There are going to be issues in doing that. But if you work through a prototype, get halfway through your project or a third through your project, and when I say through your project, I mean through your first vertical slice. What I mean is a month, not like 2 years in. And if a month in, you're looking at this and going, what if we fork the build, make a version, switch to HDRP, play with it a bit, see if we really want to, you can then change your mind. But I'm willing to bet 90% of the time it's going to be the, URP is fine.
Again, perfectly spoken. There was a question for you. Do you want to take it?
Sure. Can you explain the different rotate methods in Unity? Creating a math app, and I want to consistently rotate triangles at specific angles. Oh God. Okay. Math is not my area, to be blunt. I know enough to get by, but I'm very much
on the clock.
Yeah. No chance. Not this time. A lot of this will be ums and ahs, so I'll eat up half my time. I will say, yeah, one, I'm not the person to ask this, but I will say that it is complicated in that if you're not familiar with the concept, you have to know about the differences between radians and degrees. You have to know the differences between quaternions and vectors, and you have to choose whether you want to rotate around a point versus. It's also like 5 different ways to rotate around a point relative to whether or not you're using the transform tools. There's a lot. There's not like a simple answer I can give you. The best way, what I did, because I'm not good at this stuff myself, is I literally made a test scene. I put 2 cubes in it. I made them different colors, and I just searched online, and I found transform.rotate, or then I tried the different solutions that would create a quaternion and then change the different axes. And what if I zeroed out these ones? And I just played with it until I found something that did what I wanted to and had a better understanding. There's not going to be a direct short answer. I would say looking at channels like, 3 blue, 1 brown, whatever that channel is. There's a math channel that does a lot of this stuff that really goes into detail. Yeah, so I'm not the guy. I'll hands off. That's not my area.
Okay. I also have a take regarding rotations, which is you shouldn't be thinking about knowing the math too well, specifically because we are programmers, and when we're making a game engine, we're just calling a bunch of methods made for us. It's logical methods. So if you know that it works in one place, it should work as long as it's provided the proper input. And this is something that I think a lot of developers miss when I'm seeing a lot of 2D games and they're saying use math sin and math cost to figure out a rotation to use. I keep like shaking my head. This is not how you're supposed to think about developing your game. Knowing the math and doing it manually works. It doesn't work intuitively. And that's a big problem, because saying something dot rotate clockwise 45 degrees is way easier than saying something dot yada yada yada, figure out the math and scene of 77 and then figure out trying to figure it out with radians and doing all the translations manually. You have degrees to radians as a provided property in the mathf class of Unity, for example. Even in XNA, you have the math helper, which has the same. You have a lot of tools to just say, this is what I have, convert it to whatever you need, but give me the result that I want. And I don't even have to know any of the math involved. We have transform.rotate, we have quaternion, Euler, if you want to go with the Euler angles, which people study in schools and stuff instead of like radians.
Not even into talk about polar coordinate space as well, if you want to go into other crazy territory.
Yeah, and I mean, even just normalized directions and all that, it's a lot of tools that are available for you without you having to necessarily understand the math involved. Just make a test scene, make sure that it works as you intended, and then just take it into whatever else you need. The only thing that you have to learn is how to give things proper input and understanding relativity. Because in Unity, for example, because we have hierarchies, and things are children of other things. When you're getting something's rotation, you're actually getting its world space rotation. And there is a local rotation that is relative to the parent, but the parent may also be rotated. So you have to think about the relativity of things. But even that can be very easily solved because you get ahead the transform component that tells you, yeah, just give me the local, just give me the world version, just transform something from the world position to be relative to me. All of these methods are already available. So don't be afraid of it.
The less I have to actually know what's going on, the better. I much prefer using the simplest option available, that where it doesn't require me to know what's going on under the hood. That's how I feel with my car too.
And honestly, like I say this too, people go, "Oh, you must know all of the stuff." It's like, I'll be honest, and I've said this a million times. I think the boundary line is a million times more important than the implementation details. Because if I'm doing a Google search and I don't know how to rotate something, I will actively pick the simplest phrasing of the question I have and put it into Unity, into YouTube, or into Google or YouTube. I'll basically say, how do I rotate a thing around another thing? And if you type that in, you're bound to find 2 or 3 solutions. And if you've got a method in your project called rotate thing, and you pop the line of code in and press play and see what it does and change some of the values, if it doesn't do what you want, move it out, put the other one in, try them until you find one you like, job done. And the skill in my mind is giving yourself a way to try different solutions. That's why I talk so much about architecture, because to me the exact solution doesn't matter as much, because that can change. If the architecture is in place, you can try different solutions later. So I will frequently do something that says move character, and I'll just write move forward. And I don't want to do that. Later on, I will use a rigid body, or I will make my own Euler integration or something. But when I start, I put a boundary, I put in some code, and make it work. So you can use something you don't understand to start, and then as you start to use it more and tweak the values, you'll come to understand it better.
Just to do the question a bit of justice, and because people said when I spoke about relativity, now we need to understand the entire general relativity theory.
I was thinking that myself. I didn't say that, but I was thinking that too.
So I'm just going to do the question a bit of justice. It asks about covering the different rotate methods in Unity. Generally speaking, you have either messing with quaternions directly, which lets you multiply them to apply them directly on top of each other. The order matters there. Or you can use transform.rotate, and it has its own set of methods. There is also quaternion, angle axis, and all of those. Basically, what half of these methods are creating rotations, and half of the methods are about applying the rotations. Now, if you're just trying to apply a rotation, use transform. It's way, way easier. If you need to do things with quaternions, then learn the order of multiplication and what it means. You can make very simple tests to figure it all out. Now, as for why you're using quaternions in the first place, this is because of a concept called gimbal locking.
Gimbal lock, yeah.
Yeah. Basically speaking, we used to define rotations with Euler angles, which have 3 axes. And generally speaking, you can say put
just because it'll drive me insane, it's Euler. It's Euler angles.
Euler. Sorry.
Euler's the that's one thing.
I keep
Euler's the
forgetting.
guy's
My
name.
bad.
I will still always say Euler because I'll forget, because I didn't know that for many, many years. And you know.
Fun fact, my teacher at math at school also said Euler, so it's kind of ingrained in my head. But basically speaking, Euler angles work by using 3 different axes, which represent like a center of a clock if it spins around. The h-axis is which clock angle are you spinning around. So the x-axis, which would usually be left to right, means you're rotating forward and backward. If this is the sideways, then you're rotating like that. Then you have the y, which lets you rotate like that. That's the z, actually. You can rotate like that. And then the y, which lets you rotate like that. Now, this works, except you'll often find yourself in a situation where if you go into an angle where you're directly aligned with one of these axes, they stop mattering. For example, if you make something point straight up, it doesn't matter what angle you rotate it around, it's still looking straight up. And you lose the ability to display that information correctly. And to not have that problem, which is named gimbal locking, we ended up having quaternions, which represent rotations with 4 numbers instead of 3, and those numbers get to preserve some of that information that we lose with Euler angles. So
yeah, admittedly it's not very intuitive. It's very confusing as a concept.
Yeah, it's you don't need to care though about whether you're using Euler angles or quaternions. All you need to care about is this is representing rotation. Here is the rotation I want to have. Make that presentation work for me, because you're working with code, and the code has very simple methods: rotate, multiply, all of that. It's going to do the work for you. You just have to tell it what to do. So seriously, don't be afraid of using any of these methods, as long as you understand what they're doing.
The only things I would say, because again, I can super relate to this because math is not my area, and so I had a very hard time with this stuff, and so I can relate to where the problems are. And if there's 2 things that I think people need to understand when learning about math, or specifically rotations in a game engine, is you mentioned that the order matters, and that is something that I don't think is very intuitive to people. So if I was to say I had a shape and I rotated up and then left, you'd get a different result in different cases if you go left, up, right versus right, up, left, right? Because you're adding one rotation into another, but if you change the order of those, the combination is different. And so where this is important is it's very easy to look at your X, Y, and Z value that you get in the inspector as your Euler angles as a bit of the X, a bit of the Y, a bit of the Z. But when you look at a quaternion has 4 values. It has this W. What's a W? It's not another rotation. There's not an additional thing. It is, let's just say, magic. It is a combination of the other 3 that solves for this problem we talked about called gimbal lock. So the thing that can be very confusing when you first start is you can't just add 20 to X in a quaternion. It doesn't work like that. It does in the Euler angles. And so oftentimes if you want to do tweaking like that, you have to take the quaternion, split it back out into Euler angles, make changes to one of the axes, and then reconstitute it back into a quaternion. So that's one. Just keep in mind that a quaternion is 4 numbers, and it's different in that last value. And as for why we're saying Euler, it's named after, I forgot his first name, but I think it's like, is it Engelbert or something? The guy's name was Euler. Everyone calls it.
Was Engelbert? That would be pretty funny.
Yeah, I don't know. Yeah, but either way, it's people say now I'm just getting confused with myself. People say Euler, whatever, but it's based on his name, Euler.
Dr. Engel.
Leonhard Euler.
Yeah, and he was some name I couldn't pronounce. So yeah, that's why we're saying that. So all I'd say is they're the 2 things I think is most important. They're not interchangeable. You can't just swap the X, Y, and Z parameters of a quaternion. And the other part is the quaternion is, think of it as a just more robust rotation. It's the kind of thing that it stores more information than you need, but internally keeps it secure. Again, it's very hard to explain specifically what gimbal lock is, but the best way I picture it in my head is you've seen these things where it's consecutive rings. It's like a toy and you can spin each ring. It's like imagine a little virtual imagine you had a galaxy and you had a little model of it and you had the sun in the middle and everything's rotating around. Well, imagine if I spun two of them so they align perfectly. Now, if I'm to rotate that one, they both rotate together. They're kind of locked together in this one axis. And if we're talking about it mathematically, about adding 30% one direction, 30% another, or whatever, if you align both of those rings perfectly, you effectively remove that entire axis of rotation. You can't move in that way anymore. And so there's some problems you can't solve. You physically can't get to certain rotations anymore because you've lost one of your three toys to play with. And so that's why a representation of three values is not smart enough to handle some of these weird edge cases. So I'd recommend in general, don't worry too much. Unity will do all of the magic switching back and forth between Eulers and Quaternions for you. Just keep in mind they're not the same. Again, I wouldn't worry too much. You can get away with transform as a base object has a lot of magic for you. It has a whole load of tools in there for doing the calculations, doing the rotations. And if you're ever confused, you can basically take a Quaternion and say dot Euler angles and say, give me back the three things I'm safe with. You can play with those, and then you can say Quaternion dot Euler and put in the three values and get back a Quaternion. And so you can kind of interchange them and play with them that way. There's a lot more to this, but at a base level, you can pretend Quaternions are the thing that Unity needs, and you can live over here in Euler space for the most part.
Yeah. And once you have a method that works, you can just save that, copy paste it over and over, and never actually learn what it does because no one needs to.
True.
Yeah. And on that note, it's not unique to Unity. Every engine provides you with these tools because they're very basic to 3D space working in general. It's the same in Unreal. In regards to that, you have Quaternions just as well. You have the methods to rotate them just as well. You still have spaces, which may be local or world-based, or relative to each other if you're trying to calculate them by yourself. Nothing is going to change in that regard. And it's better that you don't have to bother yourself about the internals because they may change. For example, in Unreal Engine 5, they've swapped the implementation of the position from being a vector free of floats to a vector free of doubles because they have large worlds now. And you don't have to change any of your code if you just worked with the abstractions of positions. If you just work with the abstractions of rotations, then if Quaternions one day have to be replaced with quintillion, then you still have all of the functionality because you never wrote the Quaternion manipulation yourself.
Yep, Quaternion identity. I use it all the time. I have no idea what it does, and I don't care.
Yeah. So there was one question that we kind of skipped over as we were in our rant about rotations, spinning around, regarding how, from Rob Dinopunch, can you explain a bit about how Unity compiles C# code and serializes data? What happens after writing code and pressing play? So, Jason, do you want to have a go at this, or?
I will say I literally have a video on this. My video, I have a specific video on my channel that I will make a file, show you it compiled, show you what it's doing, make changes, see what it does. So feel free to check that out. There's more to that I need to cover, but realistically, the foundational statement of what is it doing, you'll be able to see it there.
Seems fair.
Just to answer in a bit more concrete, instead of you having to go for a video, which you definitely should because it's a good cover-up about the entire topic. Basically, Unity serializes data by figuring out which data you are actually exposing to it, either by making the fields public, which it can find by itself, or by adding the serialized field attribute, which it will look for, figure out, oh, this person wants to save this information. And then on the editor side, it's going to say, after I found all of these, if there is an object that uses the class, I am going to set you up with a visual presentation to input what you want in there. Then Unity is still keeping record in data about, for this object, you wanted this field to have this implementation of the value. And when you're pressing play, what actually happens is Unity creates the class instances for you. If you noticed, when you're working with mono behaviors, you have no ability to make an instance of the class yourself. You're using an awake method instead of a constructor. That's because Unity is making the class. And as it makes the class, it can say, oh yeah, I saved that information about the field you wanted, and I can find the field because we already did that search. Let me input the value in there. This is dependency injection done by Unity's own editor in order to give you the data that you asked for ahead of time during play. So this is what happens when you compile. It finds all that stuff. It's an extra compilation step. It iterates over the code. There's also some code generation in the background to optimize how all of that works. Then when you press play, you're playing the generated code with all the dependency injection involved, which will implement the values that you asked for, give you the class instance already set up with the numbers you wanted, and all that.
To answer one question regarding the identity concept, so one thing that, again, it's very difficult for people like myself who are not mathematically inclined, but you have to realize later that you're inheriting a lot of things from other fields. And so we talk about games as angling a weapon and shooting, but at the end of the day, we're actually talking about coordinate geometry. And so a lot of the calculation we're doing is the slope of a line or various other esoteric concepts that we originally wouldn't have thought about using. In mathematical concepts, the idea of an identity is one. It's effectively when something is defaulted to the one state. So an identity vector would be a vector where the primary axis is 1. An identity quaternion is where the diagonal along the axis is 1. So it may be confusing at first, but realistically, it's just the math nomenclature for how this stuff works. And you'll get used to it. That's all I can say.
Yeah. So there was one other question that I missed. I'm trying to find it. Yeah, earlier on, Stefan Padgam asked if game jams are a waste of time. Do you want to have a take on that?
I went to a couple game jams before, and they were fine. They weren't my favorite thing in the world, but I think you get out of it what you want to get out of it for the most part, right? You can get some community building out of it. You can get some experience, learn some new things. Definitely, you can get some cool projects out of it. I think they're good, but they may not be everyone's favorite thing to do, depending on your personality and what you're into. But I think they're great otherwise.
On my own take here, in regards to how game jams are a waste of time or not, definitely not. But you have to understand what they are actually providing value-wise, because it may not be the value that you need. Therefore, you may determine it's a waste of time. The value in game jams is that you're given a fixed time amount to make something, publish it, and then getting feedback on it. And as you have to make that within the time frame, you're making a commitment. I will ship something, which means you have to get it working. You have to make sure that users can understand how to play it. You have to figure out how to make a proper build. You have to publish it. And then you also have to deal with the feedback that comes in. And all of these steps are a very good microcosm of releasing a real product. And as you do them, you get to interact with all of these steps and learn how to do them better. Because there's the trap that a lot of new users fall into, which is they'll make a lot of projects, never reach a creative release state with them, never share them with anyone, never receive feedback, and they'll never acquire the skills that would help them a lot when they're making a real product. For example, if you've never had to make a main menu, how do you even make a main menu? You'll have to look that up. Do you need a main menu? Do you need a volume slider? How does a volume slider work with all the audio sources that you have? If you're trying to make inputs work on a specific platform, then how do you account for it? How do you use a gamepad? Do you need a gamepad? If you want to make a WebGL build, how do you even let that play? Do you need a web page for it? There are a lot of questions that a lot of people don't think about. I am making a game, the editor is playing the game, therefore I made a game. But the game is not just one scene with just one game mechanic. It can be. It's very difficult to sell that. There's a lot that gets involved. For example, making an icon for people who are trying to browse and figure out if your game is worth playing at all. You have to make something that's attractive. So that's marketing. All of these steps accumulate into the experience of making a game jam. So, and there's also the concept of working with others, which if you don't have all the skills that you need, you can team up during game jams pretty easily because there's a lot of people looking to team up. It gives you a no judgment, no difficult to find, no conditions attached environment in order to try and work with others. And that also gets you into version control and how to work together. There's a lot of skills to be gained from a game jam. But if you're already experienced in all of it, or you're determined that you don't need any of it, then sure, it's a waste of time for you.
I think there's also value in this is difficult for me in some cases. For some of us who are working on our own games, part of the reason why we like working on our own games is because we like having the control. We like being able to say, this is what the game's going to do, and let's do that. And game jams are not that. Game jams are groups of people who oftentimes have never met each other before, and everyone's going to have their own personality of who's going to take charge, who's going to follow along, and you get to learn to work with other people. And that can be challenging for some of us and easier for others. And I think, for someone like me, I've always found it a little bit more challenging because I want to move fast and do things. And sometimes I've got strong opinions, and that can be a learning experience. So for someone like me, it's actually probably a good thing to try more often and get used to working with others and working on a project that maybe isn't my favorite project, but I still do my part to make it as cool as possible. So I think there's a lot of benefits to going to them that might not be as clear up front.
Yeah, and I truly believe that what you're always saying before about the number of extra steps about it, there's that can't be overstated. And again, I always repeat this, let's step out of games for a second, because a lot of this conversation falls into, we're talking about games. We're not. We're actually talking about the wider concept of doing small sprints of a thing, of any kind of thing, if you're doing experiments or testing. If you're opening a restaurant, it's making small meals to test your ability to cook, whatever. It's the same principles across the board. And I would say in this example, you will always, always underestimate the amount of secondary things that come with a project. The best example for me would be if you were doing a Kickstarter, you'd be like, okay, do a Kickstarter for our game or whatever to earn some money to do the project. If you make a throwaway statement like, we'll put some t-shirts in as a benefit or reward, you do not realize you've just signed up for fulfillment and distribution. And fulfillment and distribution is now going to be learning different countries. And different countries have different rules for imports and different costs for imports, and then different distribution centers and different minimum stock requirements. And if you're buying t-shirts for a certain region, you have to buy a certain amount of t-shirts in a certain box size for certain countries. And now you're getting into this really weird territory where there's a lot more you never thought about. And that's one, I would say silly example, but very hyper-specific. And my point is, if you're doing a game, the only thing that matters about a game that's being delivered to the public is the public-facing experience. And how good is that experience? And there are things that you don't consider that difficult or that much value, like having a mute button or setting the volume by default to a good level and not maximum or minimum. And these kinds of things will never occur to you until you have to deliver the final product. And so the act of doing a game jam, it doesn't give you the depth and breadth you'd get from a full project, but what it does give you is a slice where you have to not only do the game, but you have to do the project management for a game, and you have to put it on the end and deliver it in a way which is going to be accepted by your audience, which means the kind of things that show up teach you about the concept of utility. And what I mean by that is when you're working on a project, it's very easy to go, the game will only be popular if it looks good, therefore I'll spend all my time doing art assets. Or, as you'll probably do 90% of the time, if you've ever done a game jam, you'll see people do this all the time. They'll spend the first 2.5 days making their game and think, we'll just throw some levels in at the end. It's like, oh no, if you didn't leave yourself a day to actually do the levels and the UI and all the other stuff, you might as well end up with nothing. You might have a really clever, really robust mechanic, but you'll have nothing to show for it because the mechanic is only as good as the framing device of the levels you've used to make it. So the game jam will teach you the full cycle of not just where do I spend my time, how do I budget my time? Where are the most valuable places to put the time? And then to remind yourself that you have to budget for things outside of your control. And the biggest one of that is, of course, that whole idea of making the game is one thing, but then polishing the game is another. And specifically the level design. And you will realize level design is really hard. There's a reason it's a separate job for a lot of people. You could have the world's best mechanic and you could deliver it in the prettiest box you can with the shiniest UI and all the best animations and all the best sound effects. But if you cannot come up with compelling levels, people will still be bored stupid. So big cycle, difficult to do. And I'll never say game jams are useless because like you'll always learn something. Even if that something is one person on your team is not pulling their weight and they're being a pain in the ass, you have to learn how to continue a project even if one person on your team is not pulling their weight. And that may seem like a frustrating thing, and it is, but it's also a valuable life lesson that will hit you later when you're working on projects and some of the people aren't pulling their weight. So it's always a learning experience. And I just think it's something I wouldn't throw away the opportunity to work with people and work on a team like that.
Perfectly spoken. Also, in regards to level design, if you tried the recent title Elden Ring, there was a very interesting piece of level design to start, which is there was a pit that you could fall into, and a lot of people didn't want to go through that pit. And that pit was the tutorial. So that just teaches you that the choices that you make there really matter a lot, because if people don't learn how to play the game, they might have a far more frustrating experience than others.
There was also this lever that just, it's...
For context for the other ones, we've talked about this in a previous show. There was some interaction issue with the starting lever in Elden Ring.
And I haven't played the game since. So,
which actually leads to a very good point. Another question that sort of skimmed by earlier that I wanted to touch on, which is someone asked, what is the common mistakes you see in horror games? And I think that's a really good topic because, well, Elden Ring doesn't quite fit into that category. It does have a lot of the same tropes and issues. And even from that, then we talked about level design, a few things I did want to mention. It's probably the most valuable. If you are come to
this is golden. He's telling all the good stuff and it's getting lost.
Yeah, your chat is lagging.
I am going to start.
Yeah, we can hear you.
Goddamn, it's my computer every time.
Yeah, okay. So
the tropes in horror, I don't know what he's going to say. I think from filmmaking, I got a film degree way back in the day, and with horror movies, the big thing is to not show the monster. You should never show the monster until in love him or hate him, but M. Night Shyamalan, I love that guy. His movies are debatable, but I actually really like the movie The Village. If any of you have seen The Village, that it's like an essay in scary movies. They basically take you through this journey of saying, hey, there's something scary, and it makes you afraid of whatever it is. And then they tell you, don't worry, it's all fake. But then they make you question that. And in the end, it is all fake, but there is something real. And it's a wonderful essay in horror filmmaking. And I think we could take a lot about that in games, too. I don't know if that's what Jason's going to say. Probably not.
It's probably not what he was going for, but if we're talking about horror games, in Amnesia, one of the funniest things for me was I was trying to play that game and I was totally scared of all the dark environment and the effects that were played off as I go around. And I generally don't play horror games, so I'm more easily susceptible to, oh yeah, this is going to happen now and this is going to happen then. But when I was trying to run away, I decided for one moment to stop and look at what I'm running away from. And this is just a walking clown model. And I just lost myself in laughing about what am I afraid of? And then it hits me that the game mechanics make you so much more afraid of what you're actually running away from than how it is actually presented. Because you're afraid of having to redo a portion of the game by game over and redo. You're afraid of losing resources. You're afraid of being stuck in an environment missing some collectible. A lot of these fear elements don't come from how the enemy actually looks. So that was pretty interesting to think about. Jason, you were saying?
Yeah. And by the way, so I figured out what I still don't know what the problem is, but I've realized that my internet tubes get clogged up from time to time. If my computer's been on too long, randomly my network it just starts going crazy and I start losing packets, and then I have to restart my computer, and then it's fine again. I don't know what causes it. It drives me insane. I have good
So,
internet,
I-
good computer,
I-
it still
Stuff.
happens.
I
Yeah.
may know what it's about later.
Okay, good, because this is driving me absolutely insane. Anyway, yeah. So the thing about horror games, right? My point is, and this might be a lot of you because I think I've done it myself earlier on in my Unity career, is you start out, decide you want to make a game. Making a game is hard. You're not foolish enough to know that it's not hard, and so you're trying to figure out what would be a good step your toe in the water kind of game. And you think about games like Slenderman, which got lots of popularity and did really well, and didn't seem like it's too complicated. I'm sure we could get some models on an asset store and pop a few things in. And so that's going to be your benchmark. You're going to make some mechanic of collecting notes, add some horror chords, Bob's your uncle, very quick game. And that's fine. I'm not saying don't do that. I think it's a good way to learn. But the problem is there's a very big issue where people will copy a game and not understand what made the game popular in the first place. And so you will surface level copy the aesthetics. You'll have the same style environment, the same be in a forest or be in a house or whatever it is. You'll use notes of paper or you'll use certain things, or you'll take a scary model and you'll have it chase the player, and it just won't feel right. There's something missing. And that's because this stuff is a lot more complicated than it looks. But for example, I've said this before about puzzle design. There's a principle of how do you make a puzzle? And one of the biggest mistakes I see is people will just put whatever sheets of paper on the ground. You go find the sheets of paper. That'll intuitively be some kind of puzzle or problem, but it's not. I don't want to say academic because there's a lot of different opinions, but the term puzzle means something different than problem. So, for example, a puzzle has a known definitive solution. A problem is something to overcome. So, if you are in a game like Deus Ex and there's something in your way, that's a problem. As in, do I hack the door to get around it? Do I shoot the robot to kill it? Do I, stealth past? Do I put on an hitman? Do I switch outfits and walk by? It is a problem that can be tackled from different outcomes. And then a puzzle can be solved using a known solution. And then with puzzles, there's different rules for telegraphing and how you would get across what you're going to do. But the long and short of this particular rant is to say the biggest mistake you can make is when you give someone a solution and they have to find the problem. And what I mean by this is a lot of horror games will have you, here's a room, here's loads of drawers and cupboards. You'll open the drawers and cupboards, you'll find a key, and now you have to find the door the key goes into. That is not a puzzle. There's nothing to be resolved, nothing to understand. There's no puzzling to be done. There is simply, I have a thing and I'm going to rub it against every surface that's key line door like until something opens. And it's subtle, but if you invert that and so that you find a locked door and it's like, ooh, where could the key be? That is a puzzle because you don't have all the information you need, and you have to, there's something in your way, and you have to, solution is a key. You have to now figure out what the solution is to find a key. Now, there's more to that, but effectively the key lock problem is indicative of the fundamental misunderstanding of puzzle design, where a lot of games at their very core don't understand the player's experience, and they'll give you these very linear adventures which aren't actually puzzles at all. And the other thing too is understanding player psychology. And this is something I learned doing Magic as a kid. Things like saying, pick a number between 1 and 10. 80% of people are thinking 7. And the people who aren't thinking 7 are probably thinking 4. Almost consistently every time, because there's a lot of reasons for these in terms of comfort for numbers. Same with 1 to 100 or 0 to 100. People will pick 68 roughly. And you can use a lot of this in magic tricks and things to guide people. And the same goes for puzzles in rooms and solving things. If I put 4 cabinets in front of me and I'm going to hide the key in a drawer, most of you will hide the key in the 3rd drawer. First one's too obvious. Last one's too far. Second one, maybe. Third one, that's probably the right one. And so even without playing your game, if you're not into puzzle design and you don't know the psychology of players, I could probably walk through your game and guess where you've hidden things without actually having to play the game, because people have come to that conclusion. For an example of this, in Heavy Rain, my friend was playing Heavy Rain for the first time. I'd never played the game. I walked into the house and sat down, and there's one bit in the puzzle where there's origami figures in a book, and your character has to make one to jog someone's memory. And I walked in. He said, "Oh," I said, "What are you playing?" He said, "Oh, I have to pick which one of these is for whatever." There's a whole load of character lore, and you have to know what it is. I just flipped to a particular page, made the thing, and solved the puzzle. And he's like, "How do you know?" I said, "Well, because it's a game designer, and game designers are going to design it that there's a certain cutscene length for each thing. They want to show you the cutscene of the first one. They don't want to bore you to the last one, and so realistically, it's probably here." And like, that's my point. Is there's a lot of this is there's a lot more information that goes into puzzle and problem solving than you think. And so if you're saying, how do I make a game, to go all the way back to our earlier statements, yes, pick a simple engine and a simple problem, because you don't know this stuff. You don't know the myriad complexities of making a good engaging puzzle, or making a good UI, or telegraphing the UI, or using affordances. And so you won't run out of things to learn. And so if the question is, what is the common mistakes people make in a horror game? They try to make a horror game by copying something and not understanding the moving pieces that made it as good as it was.
And just to touch on the last point, when you're making something and you don't know all the intricacies and complexities, don't let that stop you, though. There's a lot of games that started off not knowing half the stuff, and they still released to a successful state. Finding the fun is way more important than knowing every last nuance and detail in making the whole experience. It helps, it's not a necessity. Just wanted to bring that up.
Yeah, and that's how you learn, right? You have to make it worse and then slowly get better and whatever. So I'm not saying don't do it, but I'm just saying that it will be, if you take the smallest piece of this puzzle, this tiniest slice of this pie, it will be more complicated than you can ever imagine. And you'll come away from it having learned a lot more than you think you will. So if you pick a tiny slice and make it as good as you can, you'll learn a lot from it. And it's kind of foolish to think that you can take the huge example of a project and not trip up with all of these little micro problems, you know?
Yeah. So welcome back, Jason Weimann.
Yeah, thanks. I don't know how long I'll be back in the area. It depends on how long she stays asleep, but she's out for now, so I've got at least a few minutes to hang out until the mixer.
Yeah. So there were some questions that we were kind of glossing around throughout the entire hour regarding how C#, not C#, how events in Unity should be used, because there's somebody having quite a few problems trying to even make a prototype that relies on a lot of game events. Jason, do you want to have a go on that?
Sure. I will say, in my opinion, events are like power tools. They're very powerful. You can do a lot with them, but you can cause a lot of damage if you do them wrong. What I mean by that is, it kind of endlessly frustrates me when I'm trying to teach programming concepts that a lot of the most useful and interesting things come in the intermediate to advanced, learning the complexities of things like events, but the events only come into play to solve certain problems. And something that happens a lot, the biggest example being design patterns, is if you learn them too early, you start like slapping them on everything. It's like, this is my new favorite flavor. I'm going to put this on everything and it's going to taste delicious and taste like events. And events should solve a problem. And if you don't understand the problem enough to articulate it, to be able to say the event solves my problem, you shouldn't really be using an event here. As for the specifics, an event allows you to cross an application boundary line. I have a thing over here, I have another thing over here, and I want these two things to talk, but they don't actually work together. Then I want some way of solving that problem. There's plenty of scenarios where this works, but the problem is that particular problem has a number of different scenarios. So, for example, the relationship between you and your postman is one that's not directly connected. You're not tied at the hip and you're probably not related, but there's some relationship there. It's just hard to define what that is and how close should that relationship be. So does one of you have to hard code know the other person's address? Is there some intermediate concept like a post box that you can use between you? There's some relationship you can define in your application between the relationship between you two, and you have to know what the pros and cons of those different solutions are. Events are a very good way of defining that line, but there's a cost to that. Now, one, performance, as a few people have mentioned, a Unity event is slower than a C# event, but honestly, if you're thinking about that, you're thinking about the wrong thing. That's not relevant to 90% of the problem here. The problem is, should you be using events? Which events you use are more a matter of, is it designer-based or whatever, but fundamentally, should you be using events is the real question. And that comes down to the relationship between two objects. How closely entangled are they? In my mind, if one thing has another thing or is related closely to it, it's a waste to have an event that sort of pings up out into space and back down again versus just talking directly between two things. If two things are completely separate and you'd like to have information pass between them, events are a good candidate. As for the very specific rules I use myself for deciding, that's very hard to pick because it's not just events, by the way. We're using events as like one solution, but there's generally other things. There's callback functions, and there's strategy patterns, and there is event buses and mediators, and there's loads of other ways to handle talking between different objects that events are just one solution. And so I'd have to give a much larger conversation to explain when not to use them. I would say if I could give one bit of advice, though, with everything to do with events, which is events are very powerful because they decouple the code, and that gives you a lot of freedom to tie things together in unique ways. But the cost of that is your rule is not written down. And again, I say this all the time. The thing that makes your code different than someone else's, what's the difference between a system that's coding a bank ATM or a video game or some medical software or whatever, or monitoring software? What is the difference between these things? What if they're all programmed in the same programming language by the same person with the same UI tools in the same color? What's actually different? Well, it's the rules. There's some statement or rule in there that's if health less than this, do this. If has no money in account, don't give them money. If there is money, give them money or whatever. That's the rules. Your system is a sequence of rules and everything else is academic. So whatever language it's in, whatever platform, wherever it's placed, whatever it draws as is irrelevant. The thing that is your application that's different from someone else's is the rules. And to go all the way back to events, if you don't use events, you have to write the rule in your code. If health is less than this, do this. If you use events, you can secretly have the event rule hidden in the connection between objects. When this happens, this other thing does a thing. But nowhere in the code is that actually written down. It's implicit in the fact that when this finishes, this other thing starts. And that can be quite powerful, but it means nowhere does anybody know what that rule's intention was. If that rule breaks or that rule changes or someone wants to add new things to that rule, or you're migrating that to a different application, or you want to keep the rule but change some aspects of it, you'll have a very hard time, especially when you start cyclically doing this. This fires this, which activates this, which triggers this over here. It's like if someone was to say, what happens when I press this button? You'll be like, I don't know. Some events fire and a lot of stuff happens. Some things change color, some things activate, some sounds are played. I can't tell you because I can't point at a line of code and say, this is what happens. So events, as powerful as they are, can lead you down a rabbit hole where you don't even understand how your own application works. So I'm not saying don't use them, but I'm saying if you can't figure out what problem they're solving, then don't use them. If you understand the problem, then you can apply it. And so figure out the problem first.
Yeah. And as a means of trying to get by all of this, don't let events propagate other events, and you'll have a way easier time. If you're only using events for simplified things such as a character dies, play an explosion animation, not deal explosion-related logic other than fancy effects or audio or counting of score, then you might have slightly easier time because you're not making events that propagate into other events, creating logic between data. And then you can probably resolve the complexity way easier. Which is also, by the way, the common use of events in Unity, trying to use events as a means of resolving logical steps. For example, if you enter trigger collider, then open a door, that is using game logic within the data. And that is prone to the problem compared to just play one-offs that don't matter for other things. So there was one very interesting question that Rahul Singh asked. So an interviewer asked me why you use the job system in Unity, and I said to implement threading, but he was adamant that async or sync etc can create threads in Unity. Lol. So do you guys know what's the secret here in regards to Unity jobs versus async?
I know nothing about this.
Okay, fair.
I'm guessing. So async versus the job system. Well,
Yes.
it's how much resources it's going to, how much of the performance is left on the floor, basically, and how much it's going to use. But I guess if they want more specific answers, I'm curious what they're looking for here. But I would say you do want to use jobs over a threading, but that's only because it's the same problem with between coroutines versus threading, right? Like coroutines aren't actually threaded. Threading is multi-threaded, so you get more performance. But then as you start going higher up into jobs, you get more performance because you're going to have your memory allocated together. There's lots of other reasons, but effectively more performance as you start to go up the chain.
Entirely right. So when you're using Unity jobs, to those unaware, you're basically setting up a task that you can schedule for some point in the future with a certain amount of data, and it will try to run it ideally in parallel for whatever data set you gave it. And when it's ready, or when you tell it to complete, it will do that task and get back to you. This is the same concept as asynchronous code, but this is tightly integrated with Unity, and it also lets you use native arrays and letting you chunk the data close to each other, so that even though you're sending off a bunch of tasks into the ether and expecting them to come back to you, they can actually run the tasks way faster. There were some neat blog posts, I think, about a year ago, where somebody ran the tests, and it was like 6 times faster for roughly the same code to run in a Unity job versus using asynchronous calls and awaiting them. So it's about setting things up in a way for maximum performance versus just calling code from another thread and waiting for it to sometime later. There's also some tight integrations between asynchronous code and what happens when a failure occurs that jobs let you kind of navigate more gracefully. But this is like a small point. And if you want an example,
because it's very hard to explain this concept too, is if you're trying to deliver a letter and you go to deliver a letter yourself and maybe you fall over and you trip, you can immediately you can then respond directly by going, okay, I guess I'll go home, or I will call for help or something. If you hand a letter to somebody else to deliver for you and off they go and they trip and they don't tell you, you don't know. So if an error occurs in a different thread than yours, you may not know what's happened. And so you have to actually, like, in advance, keep track of things which could throw an error, the equivalent of like giving them a phone number and saying, if something goes wrong, give me a call and tell me. And so event management and exception handling across multiple threads can get a bit hairy, because if you've got multiple asynchronous tasks running and they crash or different things happen, managing that comfortably can be quite difficult.
Exactly. So these are some more things for you to look into regarding jobs versus asynchronous code. There was also a slightly more abstract question. How can I do a 2D game with a 3D character? Abdul Rauf Gambo asks. Does anybody want to take that, or?
We answered this a couple weeks ago, I think. But I think the general gist of it is lock the camera into a 2D thing, put the 3D character on a single line, essentially lock that character to that line, and then have the character move forward and backwards, and then they can turn. That's the benefit of doing a 3D model. I think one of the benefits is they can turn. You can choose whether they turn towards the camera, to turn away from the camera, and that's really cool. It's just a matter of locking the character onto a line, essentially. And if you're using colliders to keep them from falling, then that collider can be 3D, even if the ground that they're under is just a sprite or something. So
yeah, there's a lot of nuance to it, but generally speaking, when you're making a 2D game, you're generally drawing sprites or art that's directly built to the screen as you intended it to look. And that is often done in orthographic space, which 3D characters don't generally render in. When you're thinking of 3D, you're thinking of something with a perspective that, as it gets closer to you, it covers more of your perspective. It gets bigger relatively. When you want to make a 2D game using 2D sprites for the art related to the environment, you generally want to have the characters as well using the same kind of orthographic display. Even if I get super close, there's not really a concept of close means bigger. Therefore, the characters won't get like weirdly big around the area that's close to the camera. You can still have zoom, which means you cover a bigger area or a smaller area of the screen, but it's not the same as I am getting really close to the character's face, therefore the face covers the entire screen, like covering. If you have somebody with a big chin, like Eustace from Courage the Cowardly Dog, and you get really up his face, his chin would cover everything below. You won't be able to see that anymore. But if it's an orthographic space, it doesn't matter how close you get to his face, you can still see everything below it, because the chin doesn't cover your field of view toward that. I have no idea why I picked that chin example, but there you go. So what you want to do is generally use orthographic space. Then it doesn't really matter how you set up your colliders and all of that. You probably want to either try and do 2D physics and snap a 3D model on top of the game object where it is, or you want to use 3D and just make a sprite that's presented in the rough area of where the 3D colliders are. Either way works. If you're using 3D, then you get the benefit of, if you want to make a turning in the level or anything like that, you can probably do that. You can also rasterize the scene in a smart way to make 3D models look like 2D. It gets pretty nuanced, but there you go.
There's one topic I'd like to just briefly mention because it kind of caught me off guard earlier this week. So I was talking to a team I'm working with, and they were setting up source control. Now, there's actually technically two different teams setting up two different projects. One of them was on Git, and one of them was in Plastic. And the question came up of the meta files. And as anybody who's pushed source control with Unity, you'll get a bit frustrated getting a hell of a lot of meta files being pushed. And one of them, their instinct was, oh, we'll just turn off the meta files. They're obviously causing issues. And so I really want to just take a pause here because it occurred to me that I didn't know what meta files really were or did when I first saw them, and it's an easy mistake to make. So Unity has, so before I get into the details, a meta file, or meta by definition, is information about information. So it's meta information. So it's a meta file is a file that has information about a file. And a good example of this is if you have a texture you've imported and you've set a certain properties on it, like what its tiling is or what information, or if you've got a audio file and you've changed the compression or whatever options you want, those settings about that file or the info about that file are stored in the meta file. And so you technically don't need the meta file, as in if you put a file into Unity and it doesn't have a meta file, Unity will just go, oh, I'll just make a meta file for you because this is I will need to store information about this. Two things come up with this that get a bit interesting. One of them is when Unity creates a meta file, it creates an ID for that object, a unique GUID. And that means that it uniquely identifies that asset with that ID. All those lookups, all the asset database stuff you do are actually using the asset ID, not the asset itself. And so if you deleted the meta file and someone else has the same file on their version of the project and Unity creates a new meta file, they'll create a new ID. And anywhere where you're referencing that asset, you'll get different ones matching and it'll cause all sorts of chaos. So you do need the meta files. But here's where this can get even more confusing. One of the properties in the meta file is the last modified date. And Unity loves to change this whenever anything so much as happens. If you sneeze at Unity, it will go, oh, stuff's changed. I'll change all the meta files data for this file and everything changes. And so you'll frequently, when using source control and committing files, commit a load of meta files going, I didn't even touch these things. It's like, yes, but you recompiled the thing that thing was part of. And so it packages that up and then changes the dates of the things and stuff happens. And so this can be a bit confusing at first, but this is all to say there's two properties about meta files you need to know. One of them is either hidden or visible, and you want them visible because if you have them hidden, you might miss them when you're pushing them. And we're back to the problem I said before. And the second one is what format are they stored in? Originally, they used to be stored in binary. Now, the problem with storing them in binary is you can't really what's called diff a binary file, which is if I have one binary file, another binary file, and I want to check the difference between them, I would have to unpack them back into text so I could look at them, compare the differences, and then rebuild a binary file. But source control is really good at handling text because it's just comparing two text files, taking the bits that have changed and adding them or swapping them. And so if you store them as plain text, it can be smart enough to merge things. So if somebody made one change and somebody made another change, you don't have to throw it out and make a new one. You can just sort of squash them together and take the bits that work. So this doesn't always work, but suffice to say, you will have a better chance of getting assets to work together if changed by two separate parties if you're using the text-based meta files. Now, thankfully, by default, Unity have switched this. As of, I don't know when it was actually. Was it 2019? I think they defaulted it to text as their default serialization format. It used to be binary, which was a real nightmare. But so that's just one thing to note. If you are using source control and you haven't thought about it, you do want to push the meta files. You want to make sure they are committed, and they may be a pain in the ass, but honestly, not pushing them will cause you infinitely more problems later. So just something to keep in mind.
And also in regards to Unreal Engine's approach to that, Unreal Engine works slightly differently. They pack your assets into their own format called .uasset, and that includes the meta and the asset itself. So if you go for an Unreal Engine project and you check the files that you have, you'll see that they're all .uasset. Doesn't matter if it's a model, doesn't matter if it's a texture, doesn't matter if it's a level, doesn't matter if it's a character. They're all uasset. And that has its own advantages and detriments. So, yeah. By the way, if you're working with XNA, legacy engine here, it doesn't actually have any of the meta files. It just builds the results on compilation time into XNB files, and everything almost becomes an XNB. A font becomes an XNB, an image becomes an XNB, and audio becomes an XNB. But it doesn't matter because the XNA itself knows how to load the assets at runtime, so it's none of your problem. And all of the meta is handled in a separate project manager file for the assets that you set as part of the project.
Yeah, so I love this question. This is one I really wanted to dive into because I think this transcends testers, and I think this is one of the most valuable things I've learned in my career, and I think it's a very fascinating topic, which is, especially as someone who's done consulting, or if you work on a dev team and you're delivering to a non-technical project manager, you will frequently come up against the idea that, say, for example, you're building a website. And in my case, I was building a website in one case for analyzing the back-end data of supermarket chains' ingest files for their point-of-sale services. Fascinating stuff. But it meant they wanted a big fancy UI that lets you have charts and graphs and grids and all these interesting search data about the supermarket data. Now, I have this same conflict that you're describing here. Do I make the website first? Because the website, it's just mean stack, HTML, CSS, grab some various styling stuff. I can make it look really fancy, but it attaches to no data. Or I can go the other way. I can build the API, build the endpoints, do the calls, get the data ingested, then show some text on a screen. Now, both cases, the client is going to be somewhat unhappy or confused because they don't understand the relationship between the visual stuff and the code, how much work represents on screen. And so there's two scenarios that can play out here. I can give them the pretty UI and say, look, this is what it will look like, but there's no real data there. And in their mind, they'll be like, cool, so you're 90% done then. You just have to press a button and hook up the data. Or I do the other thing, where I show them the really like all of the text spit up on screen, and I go, there you go, all the text is there, and they're like, great, so you're 5% done. What have you been doing with all this time? Where's the website? And so they have no concept of the relationship between those two different things. So in general, and this is one of those things you just have to like learn for yourself, some people consider it dishonest, but the truth is managing expectations is part of your job. And so what I will do is I will actively do 20% of a website and then work on the back-end stuff and hook that stuff up together. So I'm setting expectations that they see a 20% done website. Then I'll go in, and even though the website may only take me an hour or two to polish up the UI, if you do that, you are giving false expectations. And so some people find that as a rough thing, or that it's like lying or whatever. But the truth is, it's about making the project go smoothly and everybody happy as a result. And the truth is, you don't want people to get false expectations. And so if you set it up so you try to marry the visuals to match the expectation of the project's build, you'll have a better time. In the case of specifically the concept of prototyping and alpha testing, what I'd like to do in those scenarios is, I've said it before, I will actively put a nice big chunky text in the corner in a semi-transparent text that says prototype. Because that's this like nice release valve for players to say, oh, whatever I see, I understand it's not done. It's very hard to do that with visuals because, again, people have no concept of this. They don't understand what's a beta feature or whatever. They're going to be entirely evaluating the experience based on how they feel, which means getting the game feel, the flow, or more accurately, their flow experience is the number one thing. It doesn't matter. You could have the prettiest environment in the world, but if you haven't done the mechanics yet, they're going to go, oh, this is very pretty, but it's a boring game, because they won't contextualize it as you haven't got all the mechanics in yet. If you put all the mechanics in yet, they'll play it and go, oh, this is fun. Pity it's not very pretty. You're like, oh, but we're going to make it prettier. Oh, I can understand that. That's easier for me to get my head around. So they are going to be judging the game on the play experience, not the visuals. And so I would say that the worry is, I wouldn't worry on the graphic side of it, because you are going to be judged more for the gameplay than you will for the graphics. That's not to say everybody, and that won't help you with screenshots. We all know that marketing is a big part of it. But if I was in that camp, I would be more than happy of making visual tests where I would do a vertical slice scene and I would set it up and do post-processing and go, this is what it will look like, as long as you're not lying to yourself and using forward rendering for your mock-up or whatever. As long as you're being honest about this is what the visual fidelity will look like, you can set a mock scene and then go back to the gameplay and make gameplay, and you could show a screenshot going, this is what the end visuals will look like, here's the gameplay you're experiencing, but they will judge you on the gameplay. They won't judge you as much on the visuals. You could have the prettiest game in the world, but if it's boring because there's no mechanics yet, nobody will care. So you want to go mechanic first as you're prototyping and testing.
Yeah. Also, on that note, even if you make the most perfect mechanics and your art looks consistent for a prototype and it's all white boxes and low poly characters or something very basic, people are still going to think, wow, this is a really interesting low poly game. And
True,
you have to communicate that the art is temporary. There's a whole art practice about picking the most unappealing things to tell people explicitly you are looking at something that will be replaced. This is why Unity's own button textures, the background color when you turn off the skybox, and all of these other things are very specific, unappealing colors. They are meant to be replaced. It's also regarding the magenta color when you have a missing asset. It screams at you, something here is to be replaced. This is why we have these ugly colors. They were not picked without intention. Also, in regarding prototyping and learning how to better make a prototype that can be communicated, there is a talk by Unity about best practices for fast game design and prototyping. And I linked it, if you can forward that, Weimann. So it has a bunch of tips about which tools you use, how you convey things, how you work in parallel about whiteboxing and letting the artists do their thing while you work on the code. There's a lot of art into making a prototype fast, easy, and well communicated. And it's a really good short talk about it.
I want to jump in real quick and just show everybody Andrew running around the Mixer Expo floor for a second, getting everything set up in there and making sure that it's all working before we go live in there. This is for everybody that's joining that signed up for the conference. We're doing the Mixer in about an hour and a half, and I should be no longer having a sleeping baby at the time, so it should be a lot of fun. We're going to just talk about game dev stuff, hang out with the speakers and a bunch of publishers and stuff, and it should be fun. There's lots of games and other things going on. Anyway, I just wanted to pop it up and show it because I got Andrew on follow mode and you're just making sure that everything is ready and working. And for the people who are coming, it should open up a half hour early, so you should be able to get in at 11:30. So in about an hour, hop in and come chat. You like the money table there, Andrew?
I haven't tried the money table yet. What's the money table?
It's the jobs discussion table. I came up with somebody recommended adding icons in Discord yesterday, and I was like, oh, that's a great idea. So I went through and started just popping in icons there instead, and it seems to be pretty good.
I just like.
So I'm gonna drop your eyes link in chat real quick.
Thank you.
And then minimize the screen so that it's not so huge.
And if you are going, feel free to drop up and say hello. We'll be wandering around. So I've had a few one-on-one chats with people about random stuff in there. It's pretty fun.
Yeah, I had a blast last time just talking to people and like introducing people to each other was a lot of fun. Just like going around and finding people that I knew would have fun conversations and kind of pulling them together off to the side and getting them to talk. So it was definitely a lot of fun. Yeah, we got little banners up for a lot of the publishers. Not all of them yet, but a lot of them. And it should be a lot of fun. I don't know. Anyway, I'm going to shut up about it to see you guys all there. Oh, somebody was asking about the $2,000 on the thumbnail. It actually should probably be updated to, I think, about $3 now. It's all the free assets in the bundle with the conference pass. people keep submitting stuff, so it's grown. There's like almost 30 things in there now. It's gotten pretty huge. But I'm gonna shut up and we'll just continue on. I'm gonna stop sharing this big giant screen now. Me following.
Is there any
Andrew.
topic that you want to talk about though? Because why shut up?
No, I mean I've just been enjoying listening to the discussion, really, especially about events and the performance stuff. It's been fun and kind of interesting just hearing everybody else's talk without me having to say much. So I'm gonna continue on with that and let you guys.
I have noticed I feel like I'm in a rant mood today, so it seems even more so than usual. I seem very on board for ranting.
He prepared you by saying this is going to be a prototype because there's a baby. So there were quite a few topics that we set up in advance to discuss, and we haven't gotten into any of them because we were just answering questions from the start of the show. Last time, I mentioned that Jason and I will be having a conversation about the recent publicity of backing field, serialized field. Do you want to have that right now or keep it for later?
Sure, yeah, I don't mind. Like I said, I don't think you maybe make it sound more dramatic than it is, but it's just the general. I guess you should start because.
Yeah. Okay. So, to those unaware, there is the serialized field attribute that people use often in Unity about private fields in order to show them in the inspector so that you can customize their starting value. When you are making something private in Unity, but you still want to expose the value of it to others just for reading, not for modification, you have to make a property that only has a get that points to your underlying field. And that usually takes only 2 lines of code, very fast, and you can change the meaning of the property later. But there has been a recent development with C# 7.3 that got very popular after some conversation recently about how you can point attributes to backing fields of properties that are auto-generated. So if you have a property that says like public int health open property get semicolon close property, that is only something that you can set via your own script. And if you put serialized field on it, it shouldn't be able to show because you have no actual field to having been placing that on that property. But if you type field : serialized field in the attribute instead of just serialized field, that will apply to the backing field that has been auto-generated for you. And then you can you'll have the inspector access to that backing field while still only having the property in 1 line of code to be used. And this is a convenient time saver. Jason Weimann has a video on this, pretty recent. But while I am a big fan of this, because I want to expose things for others to see, but not for modify, Jason Story decided that he doesn't like it. And we had a very long discussion about it. And I think I should let you take a stance here now.
Yeah, I guess I guess to kind of cover some of the earlier part of this, if you're not familiar, we mentioned before about the concept of serialization. What is serialization? Well, you take a thing, you put it in serial order, one after another, and that way you could put it into something and take it out. And if you do the reverse of when you put it in, you can maintain it. So you can take a complicated thing and basically save it out and pull it back in again. That's what all serialization at the end of the day is. If you're sending data across a network, that's all you're doing. If you're saving it to a file, that's all you're doing. There's some magic in formats and compression and other stuff. But at the end of the day, serialization means like put it in a line so it's easier to describe rather than like a complex tree of messy stuff. And so to do that, you have to be able to serialize something. And in Unity will serialize your public stuff. If you've got stuff that's public, it will serialize the public stuff for you, with some caveat exceptions like dictionaries for very particular reasons that are beyond the scope of this conversation. But if something is private, it doesn't know what you want to serialize, because you don't always want to serialize everything. And when we get into the complexities of more advanced stuff later, you might have calculated fields. So you might have not even like calculated in real time, but maybe you're keeping track of the number of of number of lives or number of kills or something, but you can regenerate that. You can like do a calculation that gets you back that information. And so saving out something that's calculated is a waste of space and memory and size for every character. So ideally, you only want to save out the things that you need to. Like maybe you don't need to save out both the position and the location of a checkpoint. Maybe just the name of the checkpoint's enough, because somewhere else you've already got saved the name of the checkpoints and their positions. So rather than saving in every place you reference the checkpoint, an additional 3 values is pointless. And so there's a verifiable reason why you don't want to serialize everything, but you want to serialize some stuff. And so that brings us to the concern. Not everything that has to be public should be serialized. Not everything that's private should not be serialized. And so you end up having this thing called serialized field. It's a nice little attribute you can slap on top of something and say, look, I've made it private so that other things can't mess with it, but I still want you to save it when you go to save it. And the other side effect is, in order to draw the editor inspector, it needs to serialize it, because without getting into a whole other rabbit hole, the way that inspector works is it's actually saving your data to an object, letting you change it, and then putting it back in when it's done. And so that whole act of doing the inspector, it's actually working on a saved copy. And so if the data can't save, it can't draw it. If it can't draw it, you can't change it. If you can't change it, doesn't get saved. So all of that is the point of serialization and the point of that serialized field. Now we get to our conflict bit here, which is at the core, fields are bits of information about an object. So if I have an animal, a field might be its name, number of legs it has, so 4 legs for a dog or whatever, whether it's what color its fur is, whatever. These are the bits of data on an object. That's the serialized field. And fields are fine. You need that to describe your object. But you don't want to be able to directly go in and imagine you had a game world where you could just go in and just change the number of legs a dog has. That's not something you want to be able to do easily. It'd be on construction. You could create a 3-legged dog if you wanted to, but you don't want that to be a thing that can be modified as an easy access. So a lot of things shouldn't be easily editable. And that's why you've got a separate concept on top of the idea of fields called mutators and accessors. So mutators and accessors let you change a value or get a value. So I might have a health value on an object, but I don't want to change the health directly. I want to say add health or set health or increase health or decrease health. And internally, I can do some magic that modifies that field, but I'm not changing the field directly.
It's important to just point out that when we're talking about restricting or making things difficult, it's to prevent further mistakes for yourself in the future or for other people working with you. Because if you expose 1,000 fields, they won't know necessarily what to access and how they correlate to each other. When you get mutators and accessors, which are simplified, they can do a lot of the work in the background for you, but you still get a clean single access point to changing things.
Yeah, and examples of this has happened in games, like a good example being you might have health between, minimum health and maximum health. And if you keep subtracting health and someone accesses the health directly, they might set the health to minus 500. And if you do that somewhere else in your code, you might do some multiplier against their current amount of health. But because the code's in negative, it might do an inverse of what you expected and suddenly break something else in your game and go, that should never happen. You should never be multiplying by a minus. Or some games have done this with your bank balance, where you do a purchase, but then you sell back during the purchase process. And when you exit, the cost becomes minus 500. And so when you exit, the game is giving you 500 currency when trying to buy something because you messed with the numbers internally. So what you can do, rather than setting the number directly, is you make a mutator. And the mutator says, I wish to set this value to minus 500. And then that object can say, actually, no, 0 is the minimum it can ever be. So before I set it, I will put a guard clause and I will limit it, and I will then change the value to 0 at maximum. So all of this is to say, these are 2 types of things. There are these fields, which is the raw data, which you don't really want to be public. And then there's these accessors and mutators, which lets you see and let you get back the objects. Now, downside with accessors and mutators, for all their power, is they're not serialized objects. They're not actually data, they're methods. And methods aren't serialized. And so if you make something that says get health and set health, that won't show up in the inspector, that won't be saved to a file, the underlying field will. So you end up with this weird territory where you do want getters and setters sometimes because they give you this guard access to make sure your values are safe, and you do want the fields, but it's now a bit chunky. The way you do that is just to write health, means you're writing health, and then a set health, and then a get health, and all the code and validation and stuff, and it's a whole load of stuff, all just so you get the basic ability to set and get a health field. And so you can kind of get around this by using a serialized field attribute with this extra field keyword, where rather than making the private field and then the getter and setter, you can make the getter and setter, put the attribute on it, and it will say, oh, I see what you're doing. I will make the field for you when I compile the application, and I will hook everything up for you, and it'll just work automatically. And that's fine. I think that's a very cool thing. And as a side note, if you do write a property method, by the way, I haven't even gotten to property syntax. I should probably have covered that. A property syntax is another like C# magic on top of that to make it look like a field, even though it's actually two methods. It makes the code cleaner. I don't know. That's a whole different conversation.
Yeah.
But I will say that when you use that, if you compile the code and then open it back up again, you'll see it's just two methods. The compiler will like unpack your property back into a get and set method. It's actually get underscore and set underscore name of your property field. That's what it'll do. And so now that I have the grounding placed, the core of the argument is I see two types of things: fields and properties and getters and setters. If you're using getters and setters, you're doing it because you want to add these rules. You want to add this: if less than whatever, don't do it, or never let health go less than this, or if I change the value, fire an event. If I'm using a property thing, it's because there's stuff I want to do around that object. Otherwise, I just use a field. And so the problem I have is that if you're using the getter and setter, putting the attribute will serialize it. It will show up in the inspector, but you can't put in those clauses. So you do get the editor serialization, but you don't get the ability to put in those clauses. So the benefits you get is you can modify the value in the inspector, but you don't get any of the other benefits from it. And so that's the one step it does. Well, that's right. I turn to you because now it's you can take it from there.
Yeah, but I mean, so when you're making the backing field have the serialization, you're still just applying that to the backing field. The get and set methods can be customized as you described freely with no problems. What you did argue, though, for is that when you're doing that, you're essentially making the names the same for the property and the field, and that doesn't let you access this underlying field from any other place. So if you're trying to make a change, for example, the declaration of what health means could change because you might have negative health and you want health only when positive and health when negative. It should still be the same underlying field, but there could be multiple properties or the properties could change. And now you're designing things so they have to change together instead of being able to abstract and make limited implementations via these properties, which have underlying values. So that was something that is hard to argue against, which has a lot of value. Go ahead.
Because my intrinsic belief is that it may be called get health, and there may be a field called health, but that's a weirdly that connection is a conceptual one that you've made, because you could say something that says get name, and there isn't actually a name field. There's a first name field and a last name field that composited make a thing called a name. That's not to say that that's now a calculated field, but the point is, there's technically no relationship between what the underlying backing data might look like versus the publicly exposed things. So sometimes you might store something in a dictionary, but it could be exposed like a list or whatever else that connection might be. So I don't see those two things as connected at all. And the idea that they can be is fine. And I'm not saying that it should be removed or anything. I'm just saying I personally don't ever see a scenario where I would like to expose something in the inspector, but then not fully encapsulated in the idea of being getters and setters. So I guess that was just a fun aside as like an area where we disagree on something as like from an approach perspective, because I guess we don't do that very often.
Yeah, we had I think it was like 2 hours of discussions on that, because we have a very varying opinion about the comfort of writing things quickly and being able to describe them with clear intent versus I have a backing field, now I have a property, now I have another property regarding the same thing. It's like, I like code that is short and clean, reads like a story that you taught me about, by the way. And that feels like the antithesis of it, because you describe things multiple times just to get basic functionality. Being able to do things as one-liners, making sure they're very clean, easy to read, and still use them with fully encapsulated scopes, like you said, sounds very attractive. So just wanted to bring that up.
And my sort of interesting philosophy on that is that I have a rule where it's about clarity of consumption, but this is why I make a very clean separation between contracts and implementation details. This may seem like blasphemy for all the stuff I've said. If you draw a boundary line that says get target enemy or something, I don't care how disgusting the code is behind that boundary line. It could be the worst code you've ever written in your life. But what you've done is you've drawn a boundary that if the time comes to clean it, or you want to try a different approach, you can just pop it out and replace it. So to me, I may come down hard on some design decisions and code clarity, but I'm actually quite liberal with the idea, providing you put the boundaries in place. And so for me, if I have an object and it's using a lot of hacky stuff inside, all of this like wrapped messy ifs and checks and whatever, as long as the exposed contract for that object is thing.getMe information, I'm happy, because whatever's inside of that, we talked before about the concept of rules. As long as the object declares its rules, I don't care how it does its rules. As long as it says to the world, I can provide this and I can take this information in and I'll do magic, then I don't mind. So I'm a lot more okay with messy, providing it's boxed in a nice, neat shape, because that can change.
Andrew, have you used the serialized field backing field?
I have not yet. I tend to forget to add serializable to classes, and then I'll be looking at my inspectors because I'm writing custom inspectors. I'm like, how it keeps resetting, and I'm like, oh yeah, I need to add that. And I also tend to put in loops into my serializable stuff where I'll like create a class that can reference other objects of the same class, and so I run into the depth of 10 that you can only go up to. In fact, one of my things relatively recently that I did was run into that issue where I couldn't save beyond 10, but I really wanted to keep this structure. So I ended up writing a JSON bit so that when I save it, I save all this sort of, I guess you can subclass or whatever, all this sub data, I save it as a JSON file. So I don't have to save the entire depth of it. I just save the JSON, and then when I load the data, I load that from the JSON, so it saves it twice in a way, if that makes sense. Yeah, that's what I've been doing with serializable stuff.
Yeah. Sorry, I'm just answering the question there. There was one question here, from a statement from Sadunazer about one of the God tier C programmers who wrote Google. People said C code was difficult to read until they saw his code, which was simple and beautiful. On that topic, I have a story from this week, which is quite the opposite, where we have code that's beautiful, but the performance is suffering because it's beautiful. And recently I had to optimize it. And to optimize it means you have to change how the code flows. And in order to change that flow, you might have to break some of the prettiness at times. To get into a bit of a more concrete topic, Terraria has a very big list of recipes in the game. There's over 2,800 of them or so, something like that. And while we were working, we were noticing that that as players move around, which they do often, the recipe list updates very, very often. Because if you run around with an open interface, you can see all of your recipes, and they have to update as you get close and far away from the crafting stations, different crafting conditions. For example, we have recipes that only show up if you're in a graveyard biome. There's a lot of very intricate conditions that keep changing the list of the 2,000 recipes that you have. And each of these recipes has to compare against all of the items that you own right now, and whether you can craft it based on if you have enough of the item. And some of these recipes also say, I accept any item of type. For example, Terraria has more than 5 types of wood, but there are recipes that will say, I accept any wood. Just you want to make a torch, just give me any kind of wood and some related material, and I will make you a torch. We also have that with iron bars and some other things. And that makes for a very, very messy condition checking whenever you want to check if you have enough materials for any recipe in the game. And we figured it's better to optimize this now. And there's a lot of takes you can have in order to optimize something. Generally speaking, you want to reduce the amount that you're polling for information. You don't want to ask the code the same question over and over. So, for example, if you counted every item in your inventory for every material in every recipe just to check if you have enough, you don't have to do that. You can check how many materials you have and putting it at the start and cash it out and say, I'm only counting the materials. I already counted them. I don't need to count them again. Just use whatever I already counted there. That saves you off from reducing the complexity of the method. And then if you're trying to check how many materials are needed, then you can figure out, for example, if you accept any wood, you could create a wood group, and then that group can count from the counts that you already counted of how many items you have, how much of any wood you might have, and then you can compare against that. And then if you and then you also reduce the group checking for every material that accepts anything. You don't have to check all the counts of all the items. You can just check the single combined count of all the items that you pre-calculated in advance. And then if you are also still checking for groups, we can say, well, I am using a dictionary of all the items that I do have and by type and how much they have. But groups aren't an item. But now we are just getting into how do you identify an item, which gets into a very interesting topic, because we can say it's just a number in the end of the day. We can say groups are just virtual items that generate in the end. And then we just put them all into the same dictionary. So we don't even have to count two dictionaries. We can count just one dictionary. And that dictionary can tell us, yeah, I'm looking for an item with the group item ID, any wood. And it would get us the combined amount of wood. We can compare against that. And then we also have to consider if we are constructing the recipe data out of proper item instances, then do we actually want to keep that? Because we don't have a virtual any wood item to present with. And if anybody's going to check that, that's an invalid item. So we can make a cache list of structs that say, well, here is the ID that you're actually looking for. And then even though we construct the recipes with proper items, underlying, we now have a presentation of you're looking for this virtual item ID and how much of it. And that gets you far better performance, because you can now also use this cached data. Instead of polling for the item itself for how much you need and the cache, you can also include the stack amount there. And now you're just using the cached objects, which can be just structs, and you can put them into a tightly packed array. Basically, code can get a lot faster if you're trying to abstract and reduce the polling that you do. And I think this is a very interesting topic to go about, because not every code that's clean and pretty is optimized, and not every code that's optimized has to look dirty. There's a lot of abstraction and of information you can do just to save yourself from steps and recalculations.
That's always the problem, right? Is that normally the solution to performance is one of three things. In a lot of cases, it's either exit early. In other words, if you can not do an operation you don't need to do, or if an operation is going to be done multiple times, you cache the results and check the cache rather than actively doing it, which is kind of what you're describing. Or you can cut out the operations entirely where possible. And so in general, the truth is, to do that tends to be more code, right? It's messier, roundabout solutions to have backups and solutions to solve things. So performance almost always necessitates making code uglier, but oftentimes the trade-off's worth it if you need to do it. It comes down to, that's why we talk about hot paths a lot, if you've heard us mention that. That basically means that you could spend ages optimizing a piece of code that gets run once and has about a millisecond cost time at the start of your application. Or you could spend that time optimizing something that is running in your actual game loop multiple times every frame. So it's not really worth running in with a heavy mindset of hyper optimizing everything, when realistically it's going to be kind of, certain things are going to massively impact the rest of your application. So if you are trying to optimize something, the first thing to think about is just simply, how much work is being done? Can I cut down on that work? Can I tell early that the work is finished somehow? And then if I have to get information, can I store the information in an easier to get way? It's almost always a cost benefit between calculation versus memory. And so you can cheap out on a lot of calculation by eating up a whole pile of memory. And that's what a lot of games do, where they just fill the memory with all of the stuff pre-calculated and buffers and textures. And if you think about it, at the very core of it, that's what a lot of things like light bakes are. They're, at the end of the day, they're saying we can either calculate it or we can pre-calculate it and pay the cost in terms of memory. So it's almost always the same solutions. It's just how do you implement them? And do you actually know a good algorithm that can quickly cut things out? In my case, I'm bad at math, so I don't tend to do this myself. But oftentimes, if you search online, you will find people smarter than you who will know that, aha, if you run this algorithm and you do 2 loops first, you can actually check and exit early rather than whatever. Or in the case of doing something like in my Discord, we talked about the palindrome check. How do you check if 2 strings are a palindrome of each other? That's one of those questions they give you a lot for testing, and it can be very frustrating because at the end of the day, you're looping through 2 things and it can be quite costly. You're doing string checks, which can be quite costly, but there's various little hacks you can do. For example, not converting to strings, using characters instead. Or if you check the first 2 characters first, you don't need to do any loops because it's not going to match if it doesn't match whatever, or if the lengths are not big enough. So you can do things like exit early, like I said. So if the strings are 0, it's not a palindrome. It's like it can't be. And so you move on and go down to the checks. And then once you do the checks, can you check early? And so from an optimization perspective, do you need to check every character is every character, or can you start in the middle and then work out? Like there's lots of ways to make it more efficient. But yeah, it boils down to the same things, and it's valuable to know, but like, again, don't start there. I always get frustrated when I see people who will spend a lot of energy on optimization when they haven't even figured out what their problem is yet. Realistically, you can run it, see where it is, and focus on those. And
at that point, we should probably get a bit into profiling and figuring out how you actually benchmark if your new solution is faster than your old one. In Terraria's case, we actually didn't have a way to poll for how quickly recipes are because we just had one method, find recipes. It would do all of the steps, and it would figure out and give you a result. Here are all the recipes. They're already set. You're good to go. But we wanted to optimize specifically for the one step that we knew was slow compared to the others because it was running more checks. So first off, you should separate your code into clean readable pieces because those pieces can then be isolated and compared against each other. So for example, we separated the counting of your items, we separated the condition checking around you, and then we separated the item checking themselves, and we have actually seen that this expensive item checking happens before the condition checking. So we could move the condition checking up because it's way faster to compare against. Now we already exit early, as you mentioned earlier. But even better, now that we have this isolated item condition checking, we can say, I am setting you up with a specific implementation of an inventory. Like, these are the counted items. You don't have to do that. I don't care about the environment condition checking. Just run this one item checking method a bazillion times and give me the average amount of time it takes. Because it's isolated, now we can do that. We can benchmark it. We can see what happens in there. And then we can make a new version of the method and calling that method with a bazillion times and seeing how much time that takes, and we can compare. And even if we don't have the science, even if we don't know the math, even if we don't know anything related to how fast our code is, we can ask brute force and see, and then make changes and safely check if we're not breaking anything as we do it. Because if the result is the same and we can compare the times, we know how faster or how slower we go. And this gets a bit into the concept of unit testing and benchmark profiling, making tests for performance, in a sense. There's also this thing where every time you run a method the first time, it's actually going to be slower. And as you iterate it more, the code is going to converge on saying, yeah, this is a hot path. I'm going to keep it a bit better and run it a bit faster. You can actually verifiably see that in our benchmark tests. The first 5 times that you run any recipe code, it's going to get progressively faster until it averages out. So running a lot of tests at once makes a lot more sense than just running one.
There's a couple more things we can touch on performance. One of them that's quite interesting is when you compare objects, it's so easy to get into the mindset of seeing objects as objects. But something you don't really think about is if I wanted to compare 2 I don't know, two video games, and I wanted to compare what the title is, who the author was, who the what year it was produced. That's a lot of information that could be quite costly to do checks. And if I was checking a database of lots of entries, that's a very slow process. So a much faster thing to check is called the hash code. Or in general, if you can turn something into a number, you can compare numbers considerably faster. And so behind the scenes, if you're using something like a list or a dictionary or, well, not a list, but a hash set or a dictionary or something, it actually does the lookups by using the hash code. And the hash code is basically generated from the fields. Without getting too much into how that works, it's just fascinating to look into because there's a lot of optimizations you can do for bucketing things. So even taking Git or Git source control as an entire concept, it's actually storing things by using SHA-1 hash of the objects. And what this means is it's got bucketed folders where the characters of the numbers are the first few numbers of their hash code. And what this means, if I want to find something, you can do a divide and conquer algorithm. So rather than searching through everything all of the time and finding the ones you want, it would be like searching for someone's name. And if you would pre-arranged everybody to line up by the alphabet of their name, you could start in the middle and then say, okay, is the person I'm looking for, does their name start with less or more than the one I'm on? And you can then jump to the next midway point and do the same thing in the next midway point. And the number of people you would actually have to check to find the person you're looking for might be 5 or 6 rather than the 1,000 or 2,000 that might be in a line. So that's one way to optimize through algorithms, by having it pre-cached in a way where the sort order itself makes it easier to find. The second thing that I think is quite useful is sometimes the medium of storage actually bakes in information. And I think this is very cool. So when you're using A-star pathfinding or a million other different types of things like that, you're using traditionally a graph. And the reason you're doing a graph is because a list is just a linear collection of things. The only relationship between object 10 is that it's close to 9 and close to 8 or whatever, it's either side of different elements. So the difference is, if you use a graph, you can bake information into the relationship. So A is connected to B, and then maybe the actual length of distance between A and B is a certain number. And that's why when you use a graph to display information, you can include information in the graph. Now, what I mean by this, a much better example, if I was making blueprints for my game, say I had some building system where you need to have this blueprint to build this, and then if you have these two elements, you could build a blueprint to build this. I could store all the blueprints as lists, and every list has inside of it a list of things that you need to build it. Now, if I want to find a matching blueprint, I would have to say, for each blueprint, for each ingredient in blueprint, does these match up? But if the blueprints build other things in the graph, I can then store it in a graph. And so I could pick any random element, and the relationship will actually draw lines to the other things that need or use this object. And so rather than doing a search or a lookup, the actual storage medium, the container I'm using to store it, houses not only what the thing is, but the relationship to other things. And if you want a real-world example of this, Google uses something called GraphDB for that little magic box in the corner when you type in a movie and it says this movie had these actors in it relevant to other movies. It's not doing a lookup for that. It's got a database stored where it's not using a relational database and it's not using a NoSQL database. It's actively using a graph where that information of this actor was in this movie, was directed by this director who also directed these movies. The ability to find all movies that this actor was related to, or the Kevin Bacon style 7 degrees, it's so much easier when you can just walk the tree and go, okay, from this guy up to that director, up to that actress, down to that movie created in this year with these other movies. You can just follow the journey, right? Because the information is actually in the storage medium. And that's why there's lots of different collection types. There's arrays, there's lists, there's hash maps, there's hash sets, there's linked lists, there's queues, there's whatever. Each one serves a different purpose because the actual container has additional information in it. And that's why it's worth knowing about this whole concept of different kinds of collections and what the benefits are. Some collections are faster to search. Some collectors are faster to get elements out of. Some elements let you get random access. You can just pick an element from the middle. Some elements you have to go through it in linear order. There's different costs and performances, but one of the biggest on-the-floor performance costs people leave is they use the wrong type of collection for the information. They could save a lot of performance by literally just storing it in a better place than the way they're storing it.
Yeah, and also if you want to get into how do you know what's faster than what without experimenting by yourself, this is already solved. It's talked about online a lot because it matters to many programmers. And the common name that you look all of this information up on is called Big O notation, which is a mathematical notation that describes how uh, values coalesce into infinity. How much are you going to grow your value relative to an input number? So, for example, if something with 10 items operates against each other of the 10 items, you're having 100 iterations. That's on to the time powered by n. And if you're only iterating once on that entire collection of 10, then you're operating just on. And if you're only operating one item, that's o1. So all of these things change a lot between whatever collections you use. If you're using arrays, lists, dictionaries, they all have different speeds for different types of things that you do. For example, accessing a single entry in an array in a dictionary is kind of fast because you already know where you hop to by an index. Lists use arrays underneath, so they're kind of the same. But if you're trying to iterate through a list, or iterate through a dictionary, you're going to find that you have slightly different performance. And all of that is already covered.
Resizing is probably a good example. If I had a list of
Yeah.
10 elements, like imagine a stack of books, and I wanted to put a book in the middle, you can't just put a book in the middle. You have to take everything off, put the new one in, and make a new stack that's the old stack plus the new one plus the whatever. And that's the general concept of a list, is you have to resize a list, make a new list or an array, and then move the stuff into it. The difference is if you use something called a linked list actually stores it completely differently behind the scenes. It uses an object related to another object, another object. It's like a chain. And if you want to add a new link to the chain, you can snip the link and put a new link in place, and everything stays exactly the same. So the act of adding a new entry in the middle is completely different in a linked list than it is in a normal list. And so if that operation is the most common thing you're doing, you don't want to use a list, you want to use a linked list. But that's slower for other things because you're using object references and there's other costs. But that's just an example of vastly different use case for something that sounds the same, but they actually work fundamentally differently.
Yeah, for example, if you use the linked list, now you're hopping between objects every time. And when you're iterating through the entire thing, you're now doing this entire hopping just to figure out where you are in the chain because you don't have a clean struct of saying, just jump to that one point. It doesn't exist because you only have chains of random
So listing
things.
them all, just printing them all out now costs you a lot more, which is kind of weird to think. But that might not be something you do very often. Maybe storing it's more important than looping through it.
Yeah. So if you want to look this up, I think there was a site called rawgit.com. It had an entire .NET Big O notation complexity list, and you can see a very clean table of everything that's in there. We covered it a few shows back, and if Jason Weimann was here, we would give you the link. But yeah. So that was the talk about performance.
I think it's very interesting because it was something that wasn't intuitive to me as well. Nothing that really made sense when I first learned it. But it's interesting to know that there's just different collection types. Another example being with the tree view in Unity, where you've got your tree of elements. I mean, you could store that as lists, or you could store it as a tree. And suddenly, the relationship between the elements is in the collection itself. So when I made my own custom tree in Unity, I made a tree, and I put stuff in a tree, and then to draw it, I just drew the tree. So it just makes it a lot easier to work with.
Yeah, and on that note, when we're talking about all of this performance stuff, it's great to know that in advance, but don't just assume that what you're looking at is the problem. Always profile. This is something I can't stress enough. People will just look at the code and say, oh yeah, that code is really slow. I need to optimize that. No, you don't. It might be code that looks really, really slow, but you might be only executing it once in the application ever. And even then, even if it has a million entries, it's only going to take 1 second of the user's lifetime, compared to something that's way faster, but can still be optimized more. And that's actually half of every frame that you have because it's a bazillion units updating against each other. For example, when you're doing distance checking and avoidance, those tend to be very expensive operations because every unit has to check against every other unit and then figure out how to move away. And if there are colliders in the way, how do you handle that, etc., etc. Processes in the hot path, things that get called a lot, matter way more in performance versus things that you do as one-offs once in a while. And when these processes break down because they have too many things to operate against, this is where you should optimize. You'll get way more benefits compared to that once extremely slow process.
Yeah, and in the case of databases, which is probably the biggest example of lots of reading data and searching very, very fast, it might seem counterintuitive, but the way a lot of those systems work is you build an index. And so you effectively take a field and go, look, this particular thing is a book, and the book has 20 properties. It has the author, the book number, the year of release, all this information, the description. But if I'm searching for a book, I'm probably searching for it by its ISBN book number or whatever. And so if I know that's the field that 80% of the time I can search on, I can pre-do a calculation on that entire set of that field to make an easier and faster to search solution. And so I actually store the data twice. I store it in the original case and I store a duplicate copy, but the duplicate copy is in a way that's faster to search. And so in some optimizations, you will have your data, but then you'll store a second copy in like a dictionary where it's the same data, but you're doing it on a different field, or you're using an index on a field that makes it much faster to search if that's a common occurrence. So sometimes that can be counterintuitive, but it's actually, if you can afford the memory, which is what we talked about before, it's either calculation or memory. You can give up memory to store multiple copies of certain things to have a considerably faster lookup.
Yeah. And that's actually something that we do often. It's exactly what I mentioned with that Terraria thing right now. The items are instances, and we say, this recipe uses wood and it has a stack of 5, so you need 5 wood. But now we're underbaking the data again into it's any wood actually, and it has a stack of 5. We're duplicating just that one bit of information. The item might have more, but we have a data set that's way faster for us to iterate on because we care about that performance there. Seriously though, when I meant about profiling, it's something I really can't stress this enough, but run your code and compare against changes, but also compare it against other code because you might be looking at the wrong thing. Don't ever assume that what you're looking at is the problem. Get a proof.
The profiler is great. It's a little hard to use for the first time you're using it and to really figure out what certain things mean, but it's when I first started, it was the way I found that I was doing things completely wrong.
It's also not always code to keep that in mind. Like one of the biggest costs, which still to this day frustrates me, is how unintuitive, not the making of, because I'm quite comfortable now with the Unity UI stuff, but you could make something that looks very pretty and well organized, but then you could be hitting tanking performance with your UI because the way you've ordered the hierarchy could lead to some really weird batching where things will like do multiple calls when it realistically could be one. And that gets really, really frustrating. So it's probably one of the biggest frustrations for me is managing the relationship between making an easy to work with Unity UI and then an easy performance UI and having to choose where you cut those corners.
This actually brings back a very interesting topic, strings in UI. So something that a lot of people don't think about or take for granted is that when you're trying to display something on a screen, if it's a word or something else, usually you just say construct it. If I want to say score colon number of score, you'll generally just type up create me a string that has that score number. But every time you create a string, because they're immutable, you're allocating memory. And if you're updating your score every frame and you're never checking against the current score, you're just saying set the score, set the score, set the score. You're creating new strings a lot. And that can completely tank performance and also like call a lot of garbage collection because you're making objects and disposing them right after setting them. So it's generally something that's not recommended. And people take it a lot for granted. And this can be a death by 1,000 cuts. You can do that in a bazillion places, and every single one of the places that you do it, you're tanking performance just a tiny bit. And then when you're profiling, you're not going to see all of that as much. You're just going to see a lot of garbage collection, garbage allocation, memory allocation, to be precise.
And there's also degrees of this too, right? Like one, your string allocation stuff could be slow, but if you switch from .NET Framework to .NET Core, it'll be half the performance cost just because it's a more tighter written backend for it. Or if it's running slow and you're doing lots of concatenations, you can switch to a string builder, which will cut out a lot of the cost of that, but there's still garbage being generated. But if you want to go even further, you can use the span of char and then do a really managed thing, and it would be even more performant. So you don't have to jump from one end to the other of being, unperformant to hyper performant. You can solve problems as and when by the degrees you need to. And oftentimes doing something like you were saying, this is slow. If I put an interim dictionary that stores a bunch of values and I look those up, you've solved 40 to 60% of a problem without having to go and ground up, rewrite a whole pile of stuff,
Yeah. Also, on that note, Jason, you talked about hashing and hash tables. There is some nuance there, but a lot of people will use dictionaries with personally made keys for those dictionaries, and they
sometimes
won't
people use game
implement-
objects. It drives me insane. Don't use game objects very often for your keys, please.
Yeah. So when you're making a class or a struct or anything, and you're using that as a key in a dictionary, if you didn't implement hashing functions or compare functions, do that. This can make, I'm not kidding, we had this case in Terraria, this can make your lookups in dictionaries up to 800 times faster, just by implementing free methods that your IDEs can generate for you at times. Rider literally has a button to say, generate these methods for me. I will be
so this
using
is the
whatever you
I comparable, the equality operator, I equatable, and what was the third one?
The hashing one, the
hash code. Get hash code.
Yeah. And just by implementing these free ones, just literally Rider it's a checkbox, make these, click, done. Your code will run faster if you're using it as keys for iteration for finding things.
Yeah, and this is there's a lot of this stuff. Whenever you have custom types, so again, a lot of people will throw out this catchphrase of switch to structs. Structs are better because they're faster. You can drop them onto the stack instead of the heap. And it's yes, kind of, but the way it works is you still have to solve this whole concept of equality and comparing. And so the way any object is compared, if you think about it, if you say, is this thing equal to this thing, what does that mean? What does a thing equal another thing mean? Does it occupy the same space in memory? Does it have the same values? Do all the values match exactly the same? Does the casing matter? What if does the name matter with the string cases? Should they be the same? You get to decide the rules for equality. And so equality isn't a straightforward thing. There's reference equality, value equality, there's your own custom type equality, there's object equality. All of these mean different things. And so by default, there is one catch-all, object equality. And it will take whatever you have, squish it down to generic concept of object, and compare both of them and say, does the compound collection of fields match the other compound collection of fields as a hash code? And it'll do that, and it'll work, but it will do garbage, and it'll generate other mess just to do the squishing down to these lower end types. And if you take your type and you implement something called I-equatable of type my type, you can manually write the code that compares the two types without having to resort to or fall back to the cache of whatever. And then there's other stuff too where you can expressly go equality comparer dot equals or ref equals and compare them yourself. This is all to say that if you do just make structs because structs are faster, it won't always be the case because you'll be caught out on things like sorting. If you want to sort one thing to another, how does it know to put one thing in front of the other? Well, it uses iComparer. iComparer is the underlying interface it uses. If you haven't implemented iComparer, it won't know how to do that unless you have to write it yourself. And so you don't get all this magic for free that you think you do. So structs are great, but you can't just use them as a catch-all for performance. You will get performance on the stack, but you won't get performance for lists and caching and various other things that you would need to manually cover yourself. So equality in C# is an entire topic worth researching because it's not intuitive. And it took me there's a great course on Pluralsight that's 2 hours long that'll go through in vivid detail why equality doesn't actually mean what you think it means.
Yeah. So that was a lot about anything related to performance. If any of you have any questions, please do ask them in chat. We'll try to answer them.
I'm glad we covered it though, because I always get the distinct feeling that people sort of brand us as being too keen on architectures if we don't know anything about calculate performance and optimization. It's no, we do it. It's just we know that it's not the first thing you should spend your attention on.
Yeah, usually just having code that's easy to understand and everybody to work on is way more important because you only need to fix performance issues as you get into them. Don't get into the pre-optimization hell there's a reason it's called hell. So yeah, that's just that. Be performance aware, don't be performance oriented, because being performance oriented is something that is a very specific job, and if you're doing that, you're generally doing only that.
I mean, you saw this, Andrew. I remember in your code, you had this thing where you're getting values and they're taking forever. So you started caching sets of values that you need so you could access the caches faster, which is exactly what we're describing. And like you saw it add direct speed to your own stuff, right?
Oh, absolutely. Yeah. I mean, I think one of the things when you were talking that I thought of that I did do, I forget the exact example now, but essentially imagine a scene with, say you've got 500 different objects that you kind of need to keep track of, maybe in the scene. The player loads and there's all these different objects. Maybe you need to keep track of where they are for the runtime, but you don't need them all at the start. You know, they're far away. The player may never actually get there. So what I did, and I think this was your advice in some way, shape, or form, was to, have the information for each one in the list, the data the data that stores all the information. But when I first get to that object and I need to actually keep track of it live, I then add it to a dictionary that is much smaller because it starts out empty. And then I first look up things in the dictionary, and if it's there, great. If it's not, then I go to the slower lookup table where I find the information I need and get it from the scriptable object, etc. But that way, throughout the rest of the runtime, I'm really only dealing with a dozen or so different things at once, and I'm just juggling those. And when they're done, I can kick them out of the dictionary much more easily, and then add the next one in when I need to. So as long as I'm not adding thousands of things to that dictionary, then it's going to be much faster than constantly looking up from the data source.
And you can do that intermediary too. So something that I did for one client project is we had TV show database information from the TV database API. And you don't have to pay the cost of performance and networking to hit their database every time. So what you do is you create something which queries your own database. And if your database is empty, it'll go to the API, get the values, put it into your database, and then return the value. Next time you ask for it, it's in the database. But the first time around, it wouldn't be. And so you get this nice sort of buffering. And then you can have, there's a whole concept of this where larger systems tend to have a kind of a Redis layer for caching. And so if I make a query, I check the fast in-memory stuff first. And if it's not there, I go to the database store and I put it here temporarily, especially because for websites and larger applications, you might have 1,000 people connecting to the same website, and they're probably going to load the same data and images on the screen, right? If I say, what are the top 10 games on my store this week? It's like, well, you're all going to see the same stuff. And so if the first person who asks for it populates the local cache, then everyone else gets that information faster. So it's the same principle. And this is used all the websites you use. And if you've ever tried to build a website, this can be an endless frustration for you because your browser does this automatically. You've seen about clearing your browser's cache. If you're trying to design a website where you change colors and art and images and you refresh the image and go, look, here's my new web page, and you change something and then refresh it and see the old stuff, it's like, why is that working? Did I break something? No, your browser, trying to be smart, has pre-cached all the old values of images, trying to save you the cost of downloading new stuff. And so you have to end up like refreshing it yourself, either manually refreshing the browser, or there's something called cache busting, which is a whole separate topic where you as a website designer can actually rename your assets as they're being used so that the browser thinks they're new assets so it doesn't store the old copy. It's a whole messy thing, but suffice to say, caching is done at all levels of your browser and internet, and it's fascinating how much of this is done to save you a lot of performance and cost.
Yeah, so that was actually a really good cover-up about caching. So there were quite a few questions that are already flying in. Overswarm asked, my question is kind of vague. How do you jump back into GameDev after hiatus with so many changes to Unity and tools? My own advice is to try and just jump in and do something that you knew that worked before. See that it already works for you. If something doesn't work or you don't remember how to do it, look up a tutorial. You'll usually, like riding a bike, you'll probably get some of the information coming back to you as you activate those neurons that already did this work before. If there's new information that you never heard of, you can look up into that and get comfortable. Generally speaking, once you know how an engine works, it's more about what other new kinds of code packages you're getting, bonuses to work with, so to speak. For example, if you already knew how to render things in Unity, just making a game object, having a mesh renderer, that's not going to change. But if you're moving into URP, now you need a different material. You still know how to render things, you still know it's a mesh renderer that does the rendering, but you're just making a new material for it. It's simpler than it seems. There's nothing to be afraid of. People jump between engines and versions of engines and frameworks and all of that pretty frequently in this industry. So it really shouldn't be a problem for you. If there is, maybe try to restudy something from the ground up. Now you're up to date on the whatever you are at, even after a long break. Nothing wrong with that.
I mean, it's not much different than coming to Unity for the first time. I mean, it's actually a little bit different because you're got a leg up. But imagine, the first time you loaded up Unity, I remember that. I loaded up Unity, couldn't get it to work, so I put it down for 6 months.
Yeah, same.
So there was a different a statement from Vitorbs about making it work and then making it fast, right? You're very close. There's actually 3 steps: making it work, making it right, and then making it fast. You said fast right, so I'll give you points on that. But generally speaking, for those not aware of the statement, when you're trying to make something, you can hard code and make a version of it that works very, very quickly, like time-wise, from the moment you get the task until it's actually working. You can probably do it pretty quickly. For example, if you just want to say, when the player dies, destroy the entire scene, you can just go and say, or the hierarchy, destroy all game objects. That works, but it might not be how you want it. So once you made it work, you can decide to maybe not hard code things, or having proper testing, implementations with customizable details, etc., etc. And then once it's working, and it's working right, so that other people can consume it as a product ready for release, for production for anybody downstream from you. If you are a programmer, then the game designer can use it properly, customizing everything, etc., etc. There's no hard coding of saying, if it's a legendary gem, then make pretty particles. You're just going to give them a setting instead. So they can say, this is an item that should play the legendary particles. It doesn't have to be that one specific gem. Just trying to make a concrete example. Then once it's ready and it's right, you make it fast. Now you're allowed to optimize if you need to. Making the code fast is the last priority in this list. First, you need a solution that actually works for whatever task you have, because that might not be able to wait on you. Then once it's working, you might be able to make it better for people to consume. Then once everybody is consuming it and happy, you can make it fast for the application purposes, so it can run on more things. So let's see. Did you guys have any question that you want to cover?
No, I think you've got a handful that were interesting to some degree.
Okay. So Vitorbs also had something here. How do you make a system that tracks multiple scores that go up really fast and ends when something reaches a certain threshold? Jason, do you want to take that?
Incremented. I'm not really sure what to.
I would just keep adding, and then if it works, it works.
But there are multiple ways you can do that, right? You can make an event that says every time the scoring changes, somebody checks it, and then if a threshold is reached, then call the score counter stop. Or you can hard ingrain it into the score system and say you can only count up to that value.
That's it. Okay, I see what you're saying. That's a good point. I guess we talked about performance earlier and various different issues. I will say, again, I always like to try to step back and find the root of an issue, or the actual real conversation we're having. And when it comes to this idea of a score, you're basically boiling down to one of two things. Do I have it constantly checking and updating and adding, or do I have some event that's triggering to do something? And the question is, why would you have one or the other, or what's the benefits or costs? Well, in general, it's a fairly blanket statement, but something that happens less often requires less performance. I think that's a fairly general, truthful statement. If I have something that happens every second, it's going to be less cost than doing it 60 frames a second, right? And so in general, as much as we talked about events having issues and there's overhead with costs of various different subscriptions, as a general rule, something that reacts to an event is going to be faster if it's reacting to something less often than happening all of the time. So my general, and again, when I say event, I don't mean Unity event. I don't mean the keyword action of the keyword event. I just mean calling a method and doing something versus checking in a constant loop, is this thing the way it should be? So as a general rule, I favor something that is event-based with that asterisk of I don't mean put Unity events everywhere. I just mean if I'm going to be setting code, we talked earlier about mutators and accessors. I like having myself have a function where I can set a value. And by setting the value, it calls a method and say, hey, this thing has changed. And so I have a place that I know will be called every time that thing is changed. And that is an event response, but it's not a Unity event or a system event or whatever. And so if the answer is, how do you do a check for something happening? Well, you can check an update and go, is it ready yet? Is it ready yet? Is it ready yet? Oh, okay, it's ready. Let's go. Or you can say, it's changed. Oh, is it changed to something I care about? No. Okay. Oh, it's changed again? Well, is it changed to something I care about? Oh, it has. Now I can respond. That'll be a lot less performance to do the checks whenever something happens than checking the same value multiple times, because that's what will end up happening. If you've got a flag that's a light switch on or off, and you write a statement in update, if is on, do this, if is off, do this, it's basically like a hyperactive kid going, is it on? Is it on? Is it on? It's still on? Is it on? Okay, it's still on. Still on. It's going to be doing that 60 times every second just while it's checking where nothing's happening. And you don't know, you know that nothing's happened because the value hasn't changed. But if you have a little piece of code that says when I change it from one to the other, do something, and that do something can do some code, you don't have to do any constant pinging and checking and dramatic updating. You can just say, oh, nothing's changed. I won't do anything. And that tends to be why people favor things like coroutines, because a coroutine is supposedly fired, does some stuff, and then stops running. It's not constantly running the whole time. So in general, this is just like, without being hyper specific to the question, if you have a choice of having something respond to events, and again, not Unity events, just the concept of something happening, like input being pressed, versus checking an update, update is 99.9% of the time going to be slower because it's literally happening considerably more often than to just respond to the rare case of an event. It's rare your event is going to be happening as many times as you're calling update. That is very unlikely to be happening.
Yeah. In Riaz, though, if you want to actually write the system and you don't know how, and the scores really do go up very, very fast, like once per frame. Like if you're checking in a racetrack how forward is each contestant, and you just want a simple system that does that and stop when somebody reaches the ending line. My own approach, just to keep it as simple as can be, is make us a winner checker system, quote unquote, that has an empty list of contestants, and every contestant, every score counter, just puts themselves in when they're joining the competition. And it can keep going and checking every time until somebody reaches the ending line, then it stops and it declares the winner and whatever have you. And that can update and create an event and call it for other things to consume, for example, to congratulate the winner or to destroy the scene, etc.
And you can combine that with something like a state machine, where the idea would be when in the game is running state, then the update doesn't feel as bad anymore because you're doing the update check only during the case while the game is running where it matters. And as soon as the game stops running, you switch to a different state and a different update is being called, and that code is not being ran because it doesn't matter. So you can still do update stuff. It's just if you are doing it, you shouldn't be like update to check the score while they're in the main menu choosing a level, right? That's not relevant information to be checking. So having things happen at stages is quite valuable.
Yeah. So Emad Tarkuni asks, is it safe to just update Unity editor in a while I'm working on a project?
No, don't touch it.
So this is a bit of a nuanced question. Generally speaking, when you're working on a project in production, do not try to update your Unity editor unless you have proper version control, which is something that should reduce the risk and fear of trying to update and breaking something. When you update Unity as editor, a lot of things happen in the background. First off, packages might be outdated, so it has to update those packages. And if things change in a package or one of your own assets has their internals changed by Unity itself, then that has to update your assets. And if your assets had something that didn't update properly, something might break. Or if Unity introduced a new bug with one of its updates, then you might lose some of the performance. Regarding the how your code ran before, and now it doesn't run the same way. And when you're updating, if you have no version control and no way to step back and actually compare, you might first say, I must have done something wrong myself. This is my fault, not Unity's. Or you might say something like, well, I guess it's always been that way and I've been ignorant, and now I need to figure out how to solve this another way. No, you might be just able to go back to your old version of the engine, say, oh, it runs better there, I'm fine like this, and I can keep going, and you can even report a bug to Unity to solve that for you later on. There is benefit in updating your project as you go on if you're intending to maintain it for multiple years. Terraria is a good example. Now we're stuck with XNA because we're already in development for 10 years, and increasing it was going to be a big breaking change. But if you have the option to update and it doesn't cause anything bad, do it, because now you're future-proofing the project if you have to make more releases in the future. This is one of the biggest problems. If you're on an old version of an engine that doesn't have support for certain things, you have to update at one point or another to get certain things. But that engine might change, might drop things on you. So, nuanced. If you have the option, take it. If you don't have the option, stay. Have a version control either way, please, I beg you. Just so you can make those checks without breaking anything.
I told the story before. I updated a version of Unity once, and the actual on Android call to resource.load was broken for one version, which meant a particular project I was working on broke on the platform device completely outside of my control, and I got a very panicked phone call trying to solve an issue that I had no idea was even an issue because someone else uploaded the project, updated it outside of my control. So yeah, I'm not saying don't do it, but like expect things to happen if you do it.
Yeah, just in general, Unity might introduce new bugs. Unity might introduce breaking changes to their own packages. I think Addressables 15 had a version update from 12 where they removed one of the methods that they first recommended using because people misused it a lot, which was a very interesting story. So it stopped working, and it would tell you it doesn't exist. And I'm like, what? I just updated the Unity project. It was there. I know it exists in Addressables. Well, it doesn't anymore. And that was updated for you automatically. So engine updates have repercussions.
Yeah, I've told stories about mine before. I don't want to spoil it again, but definitely I've run into that issue multiple times where the whole project broke, and if it didn't have source control, we would have been totally screwed. Almost missed a release date because of a 5.6 update that broke all the physics in one of the games.
I recently updated all of my asset packages to 2020 point whatever LTS. And the problem was I don't know exactly where it went wrong, but I've got one project that has everything in it, and I just move things in and out as needed, and it broke. I don't know why it broke, but the whole thing broke to the point where I just had to re-download all my own packages and rebuild that project from scratch. Luckily, it was something I could do. You could just download the assets and it worked. But I don't know why it broke. I have no idea. And unfortunately, it happened when I changed computers, and my backup drive did not somehow in the process, Apple's time machine, I thought I clicked the right button to say, yes, inherit these backups so I could back up and restore from backup. But apparently that didn't happen the first time or something, and after the first time I couldn't do it. It was very confusing. It was less to do with Unity, I think more to do with my computer, but still that could have been a disaster if it was a different project.
Yeah.
So
I mean, yeah, go ahead.
I wanted to just quickly break in and find Andrew and Gather. I think.
I had closed it.
Oh, you're not in here anymore. Okay, I was running around. I just got back in and checking out. The mixer is kind of open now. It's starting in like 20 minutes, but it's set to open 30 minutes in advance. So anybody who's ready to hop in can already kind of jump in, start checking the area out, running around, and even start chatting with people. We'll kind of officially kick it off in just about 20 minutes, right at noon. But like I said, it's open right now, so if you're registered, you can just hop right in. If you register now, just make sure that you send an email and get access so that we can get it in there, or drop a comment in chat too, so that I know and can make sure that you get access. We'll see everybody in there. I'm just gonna kind of run around, but yeah, I just want to make sure everybody knew. That was it.
Nice. In that case, let's race through the last couple of questions we didn't get to. One was there was a question about a game state, the on enter and async stuff. I don't know if you remember that one. It's suffice to say that the basic question was, writer is giving a warning about using async on a task event that's being in a state machine, and it's like, well, why is it telling me this is a performance concern? Well, one guess, and I'm pretty sure this is what's happening, is what you don't realize is when you actually use the async keyword, it's almost like, in the same way we say the new keyword and use something up and you should avoid it, async is like saying, okay, now make a state machine. And internally, it's going to build a class that manages that object. So the general advice, if you're doing asynchronous code, and it's kind of hard to explain this properly, but if you can, don't mark your methods as async. Literally just return the task itself. So instead of writing public async task blank, just write public task blank and return that object. Because when the time comes for you to call await or to call async on those different methods, it will then, kind of like how an enumerator actually runs, it will evaluate, generate a class, and then run the work through it. So you can be faster if you return objects as the tasks and then basically run all the tasks together rather than create.
Yeah. If you have.
Uh,
That was probably from the gather.
Yeah, from the gather.
yeah.
Yeah.
Okay.
Yeah, so
I
that's
had to
one.
mute that tab.
Okay.
So that's just one quick one. Just keep in mind, there's two things about tasks in general. One of them is to avoid that issue. And the second one is there's a configure await flag, which is set to true or false. That basically says, do I try to return back to the main thread after I've run this thing? If you don't need to, like you're using async void, for example, set that to false. In other words, say, don't marshal back to the main thread. And those two combinations together will make your threads faster. That was that one. And there was one other question. It was to do with, URP versus HDRP. So again, a bit confusing, not very intuitive to start with, but Unity had a render pipeline. It was an engine, it rendered things, you did the rendering, you got your project. Later on, they want to upgrade this to make it more modular. And so they end up with the render pipeline system, which is, forget about the specifics, it's just a new way of rendering, which allows you to configure a way to do it that has a different combination of settings and shaders and values and whatever. And so they made their various ones. They had a standard pipeline, a more advanced kind of fancy pipeline, and a low quality one. And after a while, they kind of realized we want everything to be on the new pipeline, just different configuration settings of it. And so they're trying to put out to pasture the old version and make the URP, or the universal render pipeline, the new baseline, the new default. And then there's other ways you can go. You can go lower or you can go higher, which has different performance concerns. But fundamentally, universal is the new baseline for replacing the render pipeline.
Now this is a horror game, and now we have the audio cues. So there was a question from Top Scout. What is your opinion about Photon, especially Pun v2? If you are familiar with it, Pun stands for Photon Unity Networking. For those unfamiliar, have any of you used it?
Yes, multiple times. I think it worked really well for small scale, non-competitive games. And then I know they have their new fusion system that they've made to actually deal with the type of games that I would have not recommended building with Photon, which is like something where super competitive, fast paced, or like high scale. They have their new system to kind of go on top of, or in addition, or kind of, I guess it's more of a replacement of that, but they support it in parallel with Pun.
So in my own case, I've used it quite a few times, just for personal projects. I am a big fan of Photon's approach, not cost-wise, but for generally prototyping and making an experience together with others, just checking things will be fun. Great stuff. Like, you can literally set up a solution and within 5 to 20 minutes have a project where you can just press play and you drop into a server, and everybody who you give a client to will also be able to drop into the same server, and you can already begin creating gameplay, just for the purposes.
You'll have lobbies, you'll have voice and everything. It'll be pretty much set up with a lot of the basics out of the box.
Yeah, and it's a single like drop-in button. You don't even have to do
You'll have
nut
lobbies,
punching
you'll have
or
voice
whatever have
and
you.
everything. It'll pretty much
We
set
can
up
hear
with a lot of
the
basics
audio
out of the
again.
box.
Oh, on mine. Oh, is that
Oh.
me? I thought I muted
You
my
say-
tab.
I'm muted on both places, so it can't be me.
Okay.
I just muted mine in here to make sure.
Okay.
All right, hopefully it's not popping up. I was not hearing anything. So. Okay.
So regarding Overstorm asking if their new system allows for rollback netcode, I believe that the new Photon Fusion has something for it. I don't recall the details off the top of my head. Rollback in general tends to be pretty difficult. Oh yeah, they do have it. They have the their own fixed time step, so they can redo the entire quote unquote physics for the game and everything else logic based by their own system, and they can roll back as needed. They still let you have things that aren't rollbacked. For example, if you want to specifically have a value that's tracked regardless, you don't want to roll back audio or anything like that. They let you do that perfectly fine. But for things that you do want replicated, rollbacked, and corrected, they have a system for that in place in Photon Fusion, not in Palm V2. Big difference.
Yeah, I also want to recommend checking out Fishnet. The creator is actually doing a talk at the GameDev Guild about his solution, and it's got a lot of these features built in, and it's a free system, so you can download it. You've got to do your own hosting, but you can self-host it for free, and then he has a paid tier, but the paid tier it's $10. I mean, it's ridiculously cheap. So it's really, really low. If you're looking for something like that and just trying to find something that's kind of new, heavily supported, and free with a good community setup, I'd check that out. And we also have a talk from the Unity team about the new netcode for game object stuff that's coming. But I think watch that talk, and I would check out Fishnet for now if you want to get into something super competitive, though, and you're trying to find an option for that, something that does like that large scale type thing, or even MMO scale. We talked quite a bit about that for the conference, and he's really responsive in Discord and everything else too. So I'd check that out.
Well, I don't know about everyone else, but if we're jumping into that soon, I'm going to need to go make a fresh coffee and get ready. So I'm ready to call it here.
Yeah, I've got I'm gonna try it. I got this up on my mobile phone, so I'm gonna be driving. So I'm gonna carefully press volume on when I'm at the right spot in this. Talk to people if you want to talk to me, but I won't be moving around.
Safety first, just like the other guy mentioned, when you're working with Unity, if you're just late by a few ms, nothing happens. But if you're in a car, that could mean death. So please be safe.
Yes, you will not see me moving about.
I assume it'd just be on audio. People come up and randomly start talking to you.
You should set it to auto follow Jason Weimann, so everywhere he goes, you'll be dragged into the meetings.
Yes,
I
you
can
can.
figure out how to
You
do that
can
from
set me to
mobile.
follow. Although right now you have to figure out how to get where I am.
I'm already next to you.
Oh, are you?
Yeah.
I think I moved. Maybe.
So,
there you are. Okay.
I can't auto. I don't know how to auto follow.
You just click on the person and hit follow. You just left click and hit follow.
It doesn't work on mobile like that. So,
Oh, then I don't
Yeah.
know. You might have to do it in the chat list.
chat list.
So you go in here and then choose follow, and it will try to follow you around.
Okay. It's pretty cool though, I have to say. Oh yeah, follow. All right.
Yeah, it's definitely a freaking cool system with all the tables and stuff. I set up all the tables for different chats. We got all our different asset publishers and stuff, and some of the sponsors are here. There's gonna be some people from Unity showing up in just a few minutes too. Should be a lot of fun. By the way, for people who aren't coming today, we're gonna do something similar for show just everybody watching the show that's free sometime in the near future, probably sometime in June. I just wanted to let everybody know that there will be something for that. This one is for attendees of the conference only, but if you're not signed up, you can still sign up and send me an email and probably get in the next 10 minutes. Yeah, I got nothing else to say on that other than I'll see everybody over there in a few minutes.
Cool.
Yeah.
Well, I guess, yeah, you got any final words,
Roy? I don't have anything specific, just that I got Nilotoon URP, and I am a huge fan of it, and I've been gushing over it for hours yesterday in Jason's Story server.
It's about half the comments in the server now at this stage.
Yeah, I gushed about it like way too much last night. There's a lot of stuff there, and I'm like trying to decipher what I'm trying to understand a lot of the mechanics there. But I leveled up like 5 times in my shader offering just by looking at the options, not even the code. So I've been very excited about that. I might have more to discuss later. And I am collecting notes as I'm going through it. But it's an experience. The manual itself has like 89 pages. So it's been a lot to go through, and like, oh god, there's a lot of there. It's like perfect stuff. In general, it's an exciting time for shader stuff. Also, I might be looking into getting Houdini and starting to try and use that myself. So I'll be having more to talk about non-destructive workflow soon. I don't have much more than that.
My only thing is just a shameless plug. If you like the low poly stuff that we've been producing, there's 3 days left on the low poly monster bundle on the Asset Store launch discount. So
is that still available? I didn't realize that was still there. I thought it was
3 more
gone.
days. I put it up for 2 weeks. Here, I'll link it for you so you can leave that. And I'm very happy. I'm actually very, very pleased and happy that it's in the top 4 of the list there. So super
Congratulations.
cool. I know. I didn't expect that. It was very unexpected. And so it makes me feel proud of that. And we should have 3 new ones added soon as they're done being modeled, and then another 12 to go into that bundle. So
Nice. Definitely go grab those and check them out. The link might already be in the description below. You want to drop it in chat as well?
Yeah, I just did it in our private chat, and
there we go. And we'll put that in chat, and it should be down in the description. Go check that out and get it while it's half off. I guess for everybody else, if you're attending the conference, we'll see you over in the Mixer in just a few minutes. If you're not already signed up, I would recommend go sign up quick. We got a ridiculous amount of free bonus items and other stuff that's coming with the pass, and opportunity to hop in and chat with everybody right now. So with that said, I guess I'll just say hit the thumbs up button, subscribe, share the stream and all that stuff, and we'll see you next week.
Bye, everyone.
Bye.
And I'll find my button and tap it.